Hello, this is Darklang for F# developers. This is my submission for F# Advent 2022. First off, what is Dark or Darklang? It is a tool or app used for building backends. You see here, this is a really basic CRUD app. And really quickly visually, I can see that this program consists of a number of different HTTP handlers, a data store, and a REPL. So Dark is a tool that comes with a number of different parts that all give you a holistic experience to create backends in this language that is also Dark. So it is a language, it is a tool for creating HTTP endpoints. You can create crons to listen for certain, to do things on a certain time interval. You can create scripts or REPLs. You can, as I mentioned, create data stores, user functions, all sorts of things. The idea is it provides you the full experience of creating backends without a lot of the traditional headaches. So anyway, so this is a tool that exists, and the goal for this video or session is to review all the interesting F# parts of Dark's code base. So Dark has its source code available. It's on GitHub right now. I'll link to it in a bit. Alternatively, you can go to Darklang or github.com/darklang/dark. But there's the backend right now is mostly written in F#. I think there's some unique parts to it. The fact that it has an interpreter, the fact that it's like hosting these totally different things. I think it's pretty interesting. It's got some neat and unique F# bits to it. But the outline to get to that goal takes a few steps. First, I'll go through what my history with Dark is, how I got into it, and why specifically interests me as an F# dev, and did interest me as an F# dev, and why I think it might be interesting to you as an F# dev. I'll go through a tour of Dark's parts. I did a very quick drive-by here of what you can do in Dark, but there's a lot more, of course, than just this screen. So I'll go through what those different parts are and why I like the individual parts. Then I'll go into why the real benefit from Dark comes from the fact that the sum is greater than its parts. The fact that Dark is this holistic experience gives you a lot of benefits. The idea that the editor and the language is tightly bound, the editor and the basically the fact that there's all these tightly bound parts is really where Dark gets its value, I think. And then finally, once we've gotten through some initial bits of here's what Dark is, we'll dive into the majority of this talk, which is the F# backend. There are a number of technologies, of course, that are used in building Dark, but the focus here is going through a lot of F# code and mostly the interesting parts that might not be in all F# repositories. I have been working on Dark for a year now, employed since February, so I will go through at the very end just a little reflection on that. So my history with Dark, I saw some buzz about it a few years ago. There's like these secretive blog posts. I'm not sure what the deal was, but I saw that Dark was a thing. I couldn't quite grok what it was. I'm not sure if it's a matter of it being in a private beta or what it was, but I saw some buzz maybe 4 or 5 years back related to it. I couldn't quite see it again because of the private beta, so I ignored it. Then a few years later, I saw 2 interesting blog posts. I'm not exactly sure the timing. Actually, let me back up here. So I saw some buzz 4 years back. I think that was around this time, maybe 2019. So maybe it's like 3 years ago. I actually think I heard of it maybe a year before this. But there are some blog posts or Twitter threads or something like that where I saw it in. This was an initial blog post that went over what Dark was at that time when it was in private beta. As I mentioned back here, there are 2 posts that later kind of brought my interest back. Those were this and this. One of them, my main takeaway was the fact that Dark was going source available, basically meaning that you can access the source code. And I thought, oh, that's neat. I love reading through other people's source code and kind of figuring out how things work. And the other bit was that the back end was planned to be rewritten from OCaml, which is an F# like language, actually inspired a lot of F#, and it was being ported to F# for a number of reasons. And so between those two things, I thought it was interesting. And I was previously hosting a podcast called WTF#, where I was just covering a number of different F# topics. And I thought, hey, Dark might be an interesting thing to do to study or to cover in one of these episodes. So I basically went into the source code, I studied as much as I could, and I got a rough familiarity with how Dark work. And I reached out to Paul, who's the one of the founders of Dark, and I asked for a podcast interview. We recorded, and that went great. And then I listened to the recording, I didn't like it. Mostly I didn't feel like I had enough context. So a year later, maybe it was 2 years later actually since the recording, and I think I have enough context to kind of introduce Dark to F# people. Anyway, so I studied the code, I had recorded the podcast episode, I abandoned it, and then I think a year after that, and maybe a little bit less than a year, I saw there was a job posting for Dark. I applied. As part of the interview, I ported some HTTP clients from OCaml to F#. There was some ongoing work to port the full of the Dark backend from OCaml to F#. And so my interview assignment was basically port these HTTP clients. In case that's not obvious, in Dark, you can, it's a full application for working in the web. So there is an HTTP client, and you can do a bunch of things you would expect to normally do. For example, if I wanted to make a quick HTTP request to my personal website, I can do that very quickly. This is not going to get anything that's super interesting here, but you can see here I have the HTTP response, as you would expect. Anyway, so my task in interviewing was to port those HTTP clients from OCaml to F#. We will look at some of that source code in a bit. And then I got the job, and then I started working in February. So it's been about 10 months since I've officially been working on Dark, but a few more months before that, I've been studying it and starting to do some porting work. So anyway, at the end of this, I'll do some quick reflection on how that year has been. Quick disclaimer, I am employed by Dark, but this video is not really related to that. It's not me trying to promote Dark or trying to get Dark in people's faces or whatever. And to that end, I might be wrong about some things. My opinions might not align with Dark's future. So yeah, disclaimer, this is just me expressing my opinion as a Dark user and a Dark contributor. This is not Stashu as a Dark employee trying to promote Dark and trying to pull people from F# to Dark. That's not what this is about. I think there's a lot of interesting F# code in here. Yeah, I got into Dark, and I thought it was interesting as an F# developer for a number of reasons. First off, it has a language. It's, this is its language. In theory, it is very similar to F#. I have, normal let expressions. I have things that I would expect in any functional language like pipes. I have things I would expect in any functional language like match expressions. Etc. I could, of course, do this, and it would, you get what my point is. It has all the stuff that it shares a lot of qualities with F# as a language itself. The fact that it was source available did interest me, and it's written at least partially, I'd say roughly half-ish in F#. The other major half being the client, which is written in Rescript. And besides the language bits that got me into Dark, the other parts of the product itself, right? The idea behind Dark is that it removes a lot of BS that comes with traditional development between waiting for CI and all that kind of stuff. So Dark is deployless. You write code and it is immediately in production. For example, if I wanted to create HTTP endpoint here for, I don't know, hello world, and have it return hello world, I could very quickly write that code, and then it is there. It's on the internet, and it's publicly accessible. So I didn't have to stand up a machine for that or deal with any kind of BS in terms of getting there. The dev environment is zero hassle. I just log in and I have a dev environment. That's great because I work from a number of different machines, my desktop here, my laptop, a Raspberry Pi, whatever. Even public computers in a rare instance, let's say you're middle of nowhere and something breaks. So as a software developer in general, especially one who works on the web a lot, Dark seemed interesting in terms of a lot of the product cases beyond the fact that it's written in Dark. So it removes a lot of headaches. 1 year in, I'd say it's been pretty interesting working at Dark and working on Dark. It's a nice code base. It's asynchronous work. There's basically no scheduled meetings. This is a product that I want. There's a lot of features that are not in Dark right now, or features that are not how I'd like them to be, that I'd like to work on over the years. So that's, lots of interesting stuff there product-wise. There's a lot of interesting stuff technology-wise and just problems to solve. This is a totally new domain to me. I previously worked in finance, grocery, higher education, maybe, yeah, I guess there's 2 in higher education. So, DevOps, not DevOps, but DevTools is a totally new world to me. So that has been interesting. The interpreter specific work, how do you go from this Dark language to executed code, that's been a whole set of interesting problems, and we'll touch on a lot of those problems when we tackle the F# Codebase itself. A lot of Dark, again, is this editor that you see here, this big canvas thing that I can drag around and whatnot. This is, I think, a lot more interesting than a lot of client-side work, or at least a lot of I've done has been kind of web formsy, not ASP.NET web forms, but you have a boring web form, you input some data, and you validate it, and it gets to the back end, and the front end doesn't do too much beyond that. With Dark, that is absolutely not the case. There is a pretty wide amount of interesting problems within the client itself, which unfortunately we won't have time to dive into today. It's really made me think about the full stack of web dev. It's, again, I've touched everything from like HTTP clients, HTTP handlers, to database connections, and I'm certain that long term we'll have to deal with performance and whatnot. So that's been really interesting. There's a lot of interesting non-technical problems that have come up. For example, you're able to just edit code directly in your editor, and it's like live, right? And so if you're working with other people, you're editing the same code base. And although that's like a technical thing you've removed of the whole like PR process of approvals and all that kind of stuff, you've then created a social problem or a process problem of how do you ensure that code is merged in safely and whatnot. Anyway, so there's a number of different non-technical problems that come up as we remove traditional technical ones like CI and such. There's a lot of these like waiting churn that can be useful socially somehow. So those are interesting problems. And then there's some stuff that hasn't really come up yet in my Dark work, but probably will, including lots of performance work. Right now, everything's in an interpreter. I imagine we'll go to a compiler at some point, or we'll add a compiler. There's a lot, and there's a lot of scaling and distributed systems work that I'm sure will come up over time. So that's my year in at Dark. So the next 2 bits here are to go over what my mental model is of the different parts of Dark. This looks like a wall of text. We will go over all these in a fair amount of detail. So we'll go over what these different parts of Dark are. I'll talk through why I think this connection between these different parts are the most useful bits. We'll go into the tech itself and the back end, and then we'll go from there. But for now, I just want to go through the different parts of Dark. And at this point, I'm going to actually turn my my face off here, and I'll dive into things in a second. Okay, so far you've seen Dark. Basically, you've seen a really basic Dark program in which I had a create, read, update, delete app with a single data store. But I've driven by a lot of Dark, and I've kind of gone through things very quickly. So very briefly, I want to basically brain dump my mental model of the different parts of Dark, and what I like about each of them. So there's a slide down below for each of these sections, so don't feel like this slide is too overwhelming. We'll get to bits in a little bit. So first off, it is Dark has a language. The language is inspired by F# and OCaml and all those ML-based languages. It also has some other attributes that are interesting to it, but first off, it has all the normal stuff you'd expect. You can do addition. We have strings. It has functions for math. For example, if I want to take the cosine of something, well, I gotta do 60.0. What else? So it's got all the normal stuff in terms of a standard library. It also has an interpreter. So the Dark language that comes with Dark, again, Dark is the only place where you can use Dark. There is no use Dark in some other dev environment, and you cannot use another language within this dev environment. These are two tightly bound things. Anyway, along with the language of Dark comes with the interpreter, which takes Dark code and evaluates it to come up with some results. You can see here, this is a Dark program, or a Dark AST, or abstract syntax tree. It's basically Dark code, and it returns a Dark result. That's the process of the evaluation using the interpreter. But anyway, Dark is a language that, like F#, cares about composable data types such as records and unions, and has a very expressive language. For example, it has everything you'd expect built in, such as match expressions, where you'd be able to do just two, not it, just one, oops, just one, it. So as this expressive language, we're able to decompose things quickly and whatnot. And along with a lot of those similar languages, it discourages local immutation. It has structural equality rather than referential equality, and it's typed. Some of these things are more true than others currently. I will kind of hand wave throughout this session over things that are either close to true or very much intended to be true. Dark is a work in progress. You can certainly use it for real applications, in my opinion, but it is not complete. For example, it is not super well protected in terms of its typing. So anyways, that's the Dark language. Of course, Dark comes with an editor. That is this big thing. I have a canvas here. You can't quite see the URL, but it's basically darklang.com/a/stashu-demo. Stashu-demo is my canvas. That is basically this program. I have a number of other programs available to me. For example, I have a Stashu Scratch program that I use for all kinds of Scratchpad purposes. I have a number of different canvases I actually am working on. I'll go back to Stashu demo though. So there's this editor. It's great on its own. It's there's no download at all. It just lives in your browser. It's fast. I can switch between functions really quickly. I can write code very quickly. Not much to say there. It's very fast. Along with the fact that it is zero download, it does have immediate updates. So if something comes out, if I just refresh my page, I have the new language features or new editor features or whatnot. So that's nice. And there's a bunch of things that come with the fact that it's integrated. For example, if I wanted to, I could highlight this code and I could extract some variable. Not the best name, but you can see here, it's just really quickly easy to get things done via the editor. Via those in-editor refactor recommendations. What am I going to say? Oh yeah, so although it is no download, if you want to, you can download a desktop app. I don't do that too often. I like kind of just working within a web browser here, but you can do it. So that's the next part of that. The next kind of piece of Dark that is in my mental model is production, or the runtime, hosting, connection, scaling. Basically, the stuff that goes from having code to that code being in production. So you're not having to stand up any servers or coordinate that code gets deployed or wait for CI or any of that stuff. Your code's just there. It's kind of like I like to think of it as a local environment that's exposed safely, where I don't have to go from local dev to production. Your local dev is basically production. Of course, there are safety measures to consider regarding that in terms of editing code that directly affects customers, but that is a problem for another slide. So that's the next part of Dark, is production. The idea that it hosts everything and deals with the connections. There are a number of bits of Dark that I'll group into the category of handlers. When I think of a handler, I basically think of what is something that has Dark code. Actually, I'll increase this font size a bit. That has Dark code and will react to that Dark code or evaluate that Dark code. For example, this is a REPL. I basically think of this as a script. This is, I guess, a really boring type of handler where you have code, it has no real input, and you can execute it. There are other handlers, of course, like HTTP, where I can define a route, and in comes an HTTP request, and out goes an HTTP response. So for example, here I might do hello, and how about I look at the request query params name. So this is an endpoint that I'm creating right now. I can open a new tab, and right now there is no query params name. So what I can do is really quickly do name equals Stashu, and it'll do hello Stashu. So anyway, there's a number of different kinds of handlers. I jumped ahead a little bit, but the REPL is one kind of handler. I think of it as a script. It can be used for either one-off tasks where you just need to get some code out or think something through. And it can also be used for, really important business processes that you want to be able to do in this kind of script-like fashion. So it's not quite a REPL right now, in my opinion. It's more of a script. So those exist. HTTP endpoints also exist, of course. As I showed right here, you can create them either by defining them and then using them, or you could also do the other way around. If I had another endpoint said, I'm going to go to a very similar endpoint. I know you can't read the URL right now, or you might not be able to. It is stashu-demo.builtwithdark.com/ and I just wrote the word hello, ? Name equals Stashu. And so I just added that hello. What I'm doing here is I am going to visit a route that does not exist. And what I can do in Dark then is look at the 404 section here. I can click on whatever just came in, and I could, in fact, I'm just going to copy paste in this case, but I could fill in the code after the fact. And what it can do is look at the request that came in before and evaluate what the response would be given that. So even though I called the endpoint before it existed and then I wrote the code, Dark is able to show us what the result would have been. And now if I go back to this web page or the route and I refresh, it will it'll be using that updated code to do that. So HTTP handlers exist. Crons also exist. I have a task right now that every day I send myself an email. I have a number of dark functions here, which are not high level functionality, but something you might want to reuse. I have functions set up for myself, and this is going to be a little bit BS here, but send email via mailinator. Body, you get the point. I can define this function, and then I can use an HTTP client to post to mailinator and whatnot. And what I'm able to do here is I'm able to use that function. Of course, it's broken right now, but in any case, I can set up this cron to do something on a daily basis. And the idea is that it gets called every whatever intervals here, or eventually we'll have better time measures set, and the code will be evaluated. So if you have tasks that need to be done every day or week or hour or whatnot, this is a tool to be able to use to do such. There are also workers for event-based processing. I have not done a ton with this, but if you define a worker, I'm just going to call it worker 1 because I'm not feeling very creative. And every time a worker 1 gets called, you want something to happen. What you can do, actually, I'm going to just bring up 2 things. I'll open a REPL that will trigger the worker and the worker itself. So the idea here is if I call this function called emit with some data, so here's some data, and I'm going to call worker 1. Worker 1. Let's see here. Then I can basically call that, and what this will do, what the worker will do, is it'll look at the incoming data for the event, and it'll do whatever you want. So you see here, I have a trace history of all of the different events that have come in. So if you have some event-based processing system, you can coordinate that within Dark very well. You can also pause and restart workers. There's a whole workflow around those. But those are for asynchronous event-based processing. Dark manages a lot of different kind of data. First off, your Dark code. You notice I didn't have to set up Git or Git history or anything like that. Dark is in charge of managing all of your code and making sure it's kept secure and whatnot. So that's a headache to not have to deal with. Dark has data stores. You see this little icon here at the data store. I can really quickly create a data store here. Let's call it blog. And we have a, let's say, title, which is a string. We have the body, which is a string, maybe the release date, which is a date, etc. You get the point. I can create a blog here, a blog data store, and I could then use a REPL or something else to see that data. So I'll drag this around here. This editor is a little bit annoying sometimes. The pieces of the canvas or these handlers will be in places that I don't want them to or whatever. That is something that's being worked on and being rethought. In many cases, I can get the command to it. Luckily, I can do this. I can add a value to that data store really quickly. So I have a value here. It's a title is my first blog post. Body, lots of text. I'm just gonna repeat this, and finally release date. I'll just put release date of now. I have to add some sort of key. I'm not feeling creative, so key 1, and this needs to go into the blog data store. And so really quickly, I'm able to insert this record in the database. I can now clear this, and if I wanted to, I could do get all and get all the records from that there. You see all the time when I'm interacting with these different handlers and whatnot, there's a lot of contextual information that's being given to me. What functions I'm calling and metadata about that, previews of intermediate data that I might be referencing. For example, my cursor is currently on blog. It'll tell me a little bit about that. If my cursor's on get all, it might tell me a little bit about that, like in the top here. And if I want to kind of direct my positioning to the definition of the data store, I can do that quickly and back and forth. So data stores are something that are managed by Dark itself. You don't have to worry about setting up a database instance and managing that and dealing with server costs and blah, blah, blah. You can also store secrets in Dark. I don't do a ton of this, but you can store, oh, I have my font size very large right now. But for example, I had some mailinator API key. I could put some long value in here. And after I've done that, it'll be generally protected while I'm working in Dark. For example, if I look at the mailinator key here, it will mask a fair amount of that. But if I want to use that in an HTTP client request, I could use that maybe in a header or something like that. And that would be included appropriately. So you can store API keys in Dark. You don't have to manage all of that. Right now, it's just key value store. There's nothing too fancy in terms of the secret management, but it is a feature. Another feature of Dark that you might have seen little bits of is all the usage data. So, you know, every time I'm making an HTTP request, for example, where's an HTTP? I'm getting a trace, one of these little dots of input. Input and output are basically stored for all handlers and functions and whatnot. Right now, we call that trace data. Along with that, we store HTTP 404s, which you saw. That's how we created an HTTP handler sort of after the fact. You can also do that with workers. Basically emit to an event that doesn't exist and then deal with it after the fact. But there's a lot of opportunity for a lot of other usage type data to be managed by Dark. For example, telemetry, explicit logs for your programs, analytics, error reports, etc. That all could be managed in Dark. Right now, Dark also has a static assets feature where you can upload, let's say, HTML files and whatnot that you'll need to support a static site. You could then use an HTTP endpoint to return that data. Let's say at the root of your website, you wanted to, what's it called? You wanted to serve some specific HTML file. Actually, I'll do serve latest. And let's say it had a file that I had uploaded called index.html. I could use this to effectively just return this as a CDN or from a CDN. So we have this idea of static assets. This is kind of an incomplete feature. We might actually remove it, but as a general thumb, Dark's management of kind of file data is something to be considered long term. And the final piece of like the different parts of Dark is the ecosystem. So we have social media and everything that allows us to communicate with users and such. We also have some docs, a blog, and a YouTube channel to document the journey and intentions and discussions and whatnot. There are collaboration tools built into Dark. If I have two tabs open, hitting the same canvas or program, you see there's this little other users icon here. You can set Dark up to be used by a team or multiple people. This will allow you to know who's around where. So for example, you see here that the other me is at this handler here. So I can click on, I believe I'm actually able to click on, no, I can't. But there's an icon next to wherever the work ones, so you know not to step on each other's work. So there are collaboration tools, but this will grow more and more over time. And the final piece of the ecosystem is the packages and the package management system. This is pretty thin right now. But we do have a number of packages for mostly related to HTTP client. In fact, maybe all related to HTTP client. These are all managed by Dark right now, but the idea is that this will be a full ecosystem of packages made by different users. Anyway, so those are the different parts of Dark and why I like each individual part. The next thing we'll do before, and this will be the last thing before we dive into code, is we'll go over why connecting these parts turns out to be really powerful. Most of the benefits of Dark come from the fact that it is a holistic product with all these things interconnected. For example, you saw briefly that you can create the HTTP handlers really fast. This is due to the fact that the traces and the editor, the handler, are all part of that same product. And you can do that either by creating the endpoint and then filling it in, or making an invalid request and then basically filling it in the other way. You can pick up where you left off pretty much all the time. I routinely switch between my laptop and my desktop, and the fact that the code hosting and the editor are one product allows me to transition between computers without having to, push code to Git and then pull from Git and deal with conflicts and branches and all that kind of stuff. I just pick up where I leave off. This little bit here about pick up the exact spot, including cursor position, is not quite true right now, but there's no reason to believe it won't be true in the future. New language features are immediately available. I don't have to wait for a new version of Go or F# or whatever to get a feature. If I have the editor and I just refresh my page whenever there's a new language feature, or in the future that gets done in a way I don't have to refresh, then I immediately have things available. That's true of language features, editor features, etc. I don't have to wait, which is nice. Speaking of not having to waiting, I don't have to wait for code to build, or for CI or deployments or anything like that. We call Dark Deployless. Anyways, that's just great. I'm tired of having to wait for CI and tests to run and builds to go and that kind of stuff. That just leaves more opportunity for me to get distracted. So the fact that these are all bundled basically provides us enough power to be able to do that. There are just a ton of tiny little benefits between the code and the editor. The fact that the editor is so intimately familiar with the language itself, there's a lot of little benefits of that. For example, if I hit, the start of a pipe key, the vertical bar at a certain position, the editor is able to look at your program and understand the context of your program and do the most reasonable thing possible given that context. Again, this is not a perfect solution right now, but there's a lot of power between these two things, in particular being tightly connected. Usage data is built in is great. It makes for easier debugging. If some user has noted that some API returned the wrong thing, well, I'm able to go to the HTTP handler, look at the recent traces, try to find their trace, and look to see, oh, well, what did it return for them? Why did this maybe break, etc. That makes for really nice debugging. So a lot of the benefits of Dark come from the fact that that it is a holistic experience. And I've listed only a few of these, but there are a ton of benefits to all these parts being interconnected. Okay, finally, I've talked enough about what Dark is and the basics of how to use it. It's this holistic editor and programming language and all that kind of stuff. Now it's time to talk about how it's built and to very soon dive into the large amount of F# source code. As I mentioned earlier, Dark source code is source available. It's not quite open source. You should read into the license and blog post about the difference there, but like 99% plus of Dark is available for you to read and contribute to. It's on GitHub at github.com/darklang/dark. You can see the file structure here. There's a README. This will generally take you through everything you need to get started building Dark. There are, we track everything through issues and pull requests here. If you ever have any feedback, happy to do that in discussions. All that's to say is Dark is available and taking contributions. Another great place to get started is to join our Discord. That's where the majority of conversations happen, besides what's in GitHub. The current backend is in F#. There's a lot of F# that is used to support the API server, which is the thing that is used by the editor to interact basically between the editor and your code. It's the way you control everything is through API server. Dark and F# also supports a BWD server, or a built with Dark server. That is where your HTTP endpoints are hosted. And there are a number of other executables also written in F#, which we'll get to. Increasingly over time, the backend will be ported to Dark. For example, that API server, the thing that supports this, we have intentions to port pretty much all of that to Dark. Hopefully all of that to Dark eventually. That might be a long multi-year project because there's a lot in API server. But as much as possible, we'd like to write Dark in Dark. One, so we get the benefits from Dark. For example, the deploylessness, not having to wait for the churn between code written and code in production, and also to remove the amount of complexity in Dark in terms of like deployment, and also just to make sure we're actually using Dark and being users of Dark so that we understand where its problems are. The front end is written in Rescript. Rescript is, like TypeScript, it's a JavaScript. It's a language that's compiled to JavaScript. It's basically an OCaml in the front end. Rescript used to be called, I forget the whole history to it, but it's a language that feels like ML or OCaml or F#, and it's in the front end. I'll give you a really quick peek at it. In our client code, this is what Rescript looks like. It kind of feels like an F# plus TypeScript to me. Anyway, I won't go into too much about that. If anyone's curious, the client could take its own hour or multi-hour long video. We host on GCP. It's Google's cloud platform. We use Postgres for data stores, etc. There's a bunch of different tools that we use for hosting, infrastructure, data, whatnot. I'm not going to dive into all of those. I actually am not going to draw here of how Dark works. I think that'll become somewhat obvious as we go into things. So the next thing I'm going to do here is I have a goal of basically visiting every F# file within Dark's codebase, which is quite a bit. I've pulled the repository down here. I have a backend folder. This is where all the F# is currently. There is quite a bit of F# code. So this is maybe an ambitious goal, but my goal here is to visit almost every file in the backend repo, backend directory of the Dark mono repo, and certainly focus on the things that are interesting and unique to Dark, but generally give a feel for how this all works. So I have a certain algorithm that I use when I am trying to study a code base, and this is what I used. I've used this to study Fable. I've used this to study Dark, a number of other projects. And basically what I'll do is I'll clone the repository. So I'll git clone Dark into a new folder called Dark Demo. I'll cd into Dark Demo, and I will use a command. You might not be familiar with it. It's called tree. And what tree does is it basically recurses through your, I'm on Linux right now. It's a Linux program that will recurse through your directories and basically output all your files that are there in a tree structure. So you can see all these files exist. And what I'll do is I'll take this and I will get to a point where I have a Dynaless document that, not this one, but not this one. this one is what I want to look at, that reflects the code there. So I'll basically output the results of tree and get them into a shape that I can start massaging in Dynalist, and basically check off certain pieces as I go. In case you're curious how I do that, I have this command here. Oh, is it not allowing me? No, it is allowing me to copy. What I'll do, I'll clear this here and I'll paste that in. Oh, there we go. Is I'll basically do tree of the backend directory. I'll do some magic. This is copied from Stack Overflow. I don't know how it works, but I'll do some magic that'll basically remove all of the indentation noise here, and I will put that into a tree backend file. I will then open that tree backend file in Sublime Text. Of course, that's not going to the file that I want to, so I will just do this. Let's see. That'll be in home, code, and then where, yeah, dark demo, and then tree backend. So I'll take it to Sublime. I know I need to do this trick here to remove some BS characters. Then what I can do is I can copy paste, and I go to Dynalist, which is a great piece of software, by the way, where you can manage notes and whatnot in a nice top-down kind of a hierarchical bullet point fashion. And I will simply paste that dump of stuff here. And that'll tell me how many files are there and whatnot. There's a lot of stuff here. You see 1,900 files. A lot of those are test files that, of course, we're not going to cover. 2,000 files. But I'll get to a point where I have something like this, where I have a document that outlines the files that I want to study. I will organize that a bit per folder to something. Oh, I didn't mean to close that. I will organize that to a point where it looks something like this, where I have the same folder structure, but I might sort the I might do some rough sorting of individual projects or files within a project or whatnot. For example, I'll put like readmes at the top of the file. So I'll massage that to a point where it's like this, and then the final thing I'll do is I will do a final organization for like, okay, well, conceptually, what are the files I need to study, and I'll go through that. So anyway, this is all a long-winded way of saying that the goal here is going to be going through all of Dark's F# backend, and the tool that I'll use to drive that is this this giant list of files here that you'll see. Again, a lot of the stuff will be tidied up. In fact, I'll do that a little bit while I'm talking now. And I won't. I'll just leave it. So anyway, the goal is at the end of this that all of these checkboxes are checked, and you will feel comfortable, generally speaking, with what Dark's F# backend looks like and how it's composed. I will actually collapse all, and you can see the different sections. So that's the plan. There are a number of F# artifacts, things that are either executable or usable in some way that are a result of the F# code. There's like this thing I'll call the core, which is the language, the fact that we can eval or interpret that code. There's a standard library, and the functions that come with that. There are packages, and then there's of course your program or code or canvas. So those are like some of the artifacts. Of course, these aren't necessarily the artifacts of F#, but I'm saying this is part of like the core. And in terms of core F# artifacts, there's the BWD server, which is used to support HTTP clients. BWD stands for Built with Dark. There's the API server. This is used for the editor. It's all the interactions between the editor and your code and your program. There is some F# that is compiled via Blazor to WASM or WebAssembly, We use that for analysis. I'll talk through briefly how that interaction works. I think that's pretty interesting, and I've spent quite a bit of time there. And then there are other kind of one-off artifacts for dealing with crons and queues. Queues you can also think of as workers. So those are the F# artifacts. Oh, and that is my last slide for a while. Okay, so the goal from this point will be to go over all of the F# source code in Dark. So at least the majority of it. This is VS Code. It's the editor we use to write Dark in, Dark source code anyway. There's a number of different folders here. Of course, the backend is not the only part of this, although it is a very large portion of it. We also have a client. We have, integration tests, documentation, configuration values. We have some stuff to deal with CI/CD and hosting and infrastructure and all that kind of stuff. But for this video, all we care about is this backend directory here. And so the goal is that we, and this is basically just really one F# solution called FS_Dark that we use to output all of the artifacts that I just mentioned, including BWD server, API server, etc. If we take a quick peek at the source, you'll see a number of different F# projects from the API server and BWD server to many other supporting libraries. And so what I've done here is I have organized all of the files that are in this directory here into different sections. So we'll first go over general .NET stuff, I don't know what happened there. Just .NET stuff that you would see in any F# project. We'll touch on what NuGet packages we use and why we use them, and the fact that we use them via Paket. We'll go over general code baseline stuff. This is stuff that is like infrastructural that you'll find in any F# project. For example, database connections, right? Everyone needs to connect to a database. This is not really interesting, particular to Dark, so I'll kind of breeze by that. Next, we will go over the language itself, the definition of an integer and a string and all those different fun language parts. And so the definition and also how the language is interpreted. We have an interpreter that's used to evaluate expressions and come up with results. So we'll go over how that works. We'll go over the standard library, specifically the non-backend standard library. This is a subset of stuff that can be WASM compiled and whatnot, but in any case, there's a standard library and it's split in half, and we'll talk about why that is and what those two halves are. We'll then talk about Dark's backend and the modeling of it beyond just the language. So in this section, we'll cover the language and how it works, but of course, that doesn't cover, okay, well, we have a language, what does a canvas look like, what is a REPL, and how is that modeled, all that kind of stuff is modeled in Lib.Backend, or at least the majority of it's modeled in Lib.Backend. After that, we'll talk about the Backend-Only standard library. These are the parts of the standard library that must be executed on the backend, for example, connecting to a database or things like that, anything that requires running on a backend rather than on the client. There is this concept of real execution, which really just bundles together a number of things above in this list. We'll cover HTTP clients, where I've spent a fair amount of area. I mentioned earlier at the start that my first task in Dark was to port these HTTP clients from OCaml to Dark, or to F#, sorry. We'll talk through HTTP handlers, how we handle these HTTP endpoints and deal with routing and all of that. We'll talk very briefly about secrets and the management of those. We'll talk about user databases and how we manage those. The client and editor, how we interact between this editor experience and your Dart program or code. Traces, these little icons around here where we record the inputs and outputs of various pieces of your code. Those are traces, and we'll very briefly touch upon that. That is currently in flux, and I'm also ignorant of this area, so we won't touch too much on there. We'll talk about in-editor evaluation. This is the WASM compiled piece of Dark, of our F# code base that we compile basically our backend, some of our standard library and whatnot. I guess not quite this. I guess we compiled this much at least. Yeah. Anyway, so we compile some portion of our backend into WebAssembly, and we use that on the client. We'll talk through how that interaction works, how's the Blazor compiling work, all that kind of thing. Talk through crons, queues, workers. We'll talk through the Dark user accounts and the management of those. And then there's some stuff that users don't really care about, but we do. How do we run Dark? There's plenty of stuff, for example, like Kubernetes stuff that is not relevant to our users and their users, but is relevant to us. And then there's just some miscellaneous stuff that I couldn't fit anywhere else. Okay, so let's dive into it. The first section we'll look at is the general.NET stuff. There is a file in the backend directory called global.json. This is where we basically register what SDK version we're using. We're using 6.0300. We do intend to upgrade to .NET 7 very shortly. Specifically, there's some improvements we expect for the Blazor or WebAssembly compiled portion of our code. But that's pretty much it. There's not too much that's going on here. The next piece is NuGet config. We're not using any fancy package sources. We don't have a private NuGet repository or anything like that, so this is boring. We have two SLN files, or solution files. If you're not familiar with .NET, this is basically it's basically a grouping of what projects within these directories should we compile when we want to compile a larger thing. At least that's how I think of it. There's not too much to say here. It basically references a bunch of projects, and it also references some specific files that should also be considered the project, even if they're not necessarily compiled, for example, or README. So there's these two solutions. There's not much to them. I don't look at these too often. They're pretty much all automatically managed, so I'll check these off. The only difference between these two is I think FS Dark contains a few more things. For example, it'll contain the test projects and all that, whereas FS binaries may only include just what's enough to actually run things. And the reason it might be useful is maybe we use that in CI. Maybe we only release build the binary projects. I forget why we have those two split, but we do. And the final boring general.NET thing to look at here is the directory build props. And I don't actually know what this does. I don't think I ever have, and it hasn't come up yet, so I'm going to effectively ignore it and just claim it as something that's not really interesting in Dark. So that is the first section, nice and easy. Okay, after baseline .NET stuff comes dependencies. So we have a number of different NuGet packages that we pull in. Actually, I guess quite a few. And so I want to look at this packet dependencies file and touch on briefly what it is for anyone who's not familiar with Paket, and then briefly talk about packet.lock or paket.lock. So Paket is a tool that is used to pull in and manage dependencies, basically other artifacts or code or compiled code that we can use in our own project, so we don't have to build everything ourselves. I will just go down the list here and explain what packages we use. As far as I know, there are some of these that I have a very rough familiarity with that I won't be able to speak to as well. But we use Newtonsoft JSON for some JSON serialization, basically converting between in F# objects and JSON. So we use these sometimes across the seam. We're actually trying to limit our usage of this as much as possible. I'm not sure how much of this is left. There's not too much. And we're generally migrating to system text JSON for JSON serialization and deserialization. We use a tool called Tablecloth, which provides a lot of baseline stuff for working in F#. This is similar to maybe F# Plus. I think these are actually similar products. I'm not totally sure. Tablecloth is something that is hosted by Dark. It's a project that kind of got born out of working on Dark, I believe, and so we use that. We use Ply, which is something to do with async. I forget the advantages there, but provides us a number of different benefits related to dealing with asynchronous code. F# Plus, I think this just provides us a few functions and modules where in types. I'm not actually sure how much we use this, but apparently we have it pulled in. We have fsregex, which no doubtly is used for regular expressions. Again, F# core is just, it's just F# built in. I guess it should be more towards the top. I guess it's, I was going to say it's alphabetized, but it's not. I have no idea what faith life utility is. I mentioned we use system text JSON. We also use two extensions for helping us work with system text JSON. There's one that handle F# type specifically, for example, discriminated unions and records. The default serializers in system text JSON don't do a fantastic job with F# types, so we use that for F# types, and we also use Notatime for dealing with time management, storing dates and timestamps and all that kind of thing. And so we have a similar, similarly, we have a NuGet package for serializing those Notatimes. We serialize some data to disk in what we'll call binary serialization. So try to keep it really minimal rather than JSON, which is very wordy and human readable and whatnot and more universal. We use message pack to store most of the program data to Postgres tables, to Postgres databases rather. So we have message pack and we have some extensions around that. We use a number of different tools for testing. Expecto and fscheck are the main ones. You can go check those out. Those are great tools for writing tests in F#. We use the F# compiler service, which allows us to kind of act as the F# compiler, or to manipulate F# code in F# code. We use this for tests because we read test files, which we'll get to, and we basically turn them into Dark code. So we parse an F# AST, and we transform that into a Dark AST, and we execute that code. I think that's a pretty neat thing we do. I don't know what this is. I guess we log to some file somewhere. I'm guessing that's actually related to the fact that when you run tests or do anything in Dark, we have this run directory with a logs file on it, and we have log outputs for various pieces of the backend and infrastructure and whatnot. And so maybe this is helping us log to file there. I don't know what Simplebase is. I don't know what Lib.ASP.NET Core server timing is. I'm guessing it's related to, some timing aspect of recording. Maybe it's timeout, or I don't know. I'm not sure what that is. We use a tool called Pusher to push updates, or rather push messages from the server to the client. So that NuGet package helps us out with that. We use Rollbar to send error reports and other informational packages to a service called Rollbar, so that they have an official package that we use, apparently in beta version. We do various health checks on our different services, so we have some NuGet packages related to that. We use this thing called Darkly, or Launch Darkly, This is not a dark thing. That got me confused for a while. Darkly is a feature, basically a feature flag tool in my head. It allows you to externally configure various settings to be used in your program externally, and we have this NuGet package that helps us. It basically acts as a client for Launch Darkly so that we can turn things on and off externally. But this is not a dark built thing. That got me confused for a while. We use Google PubSub. I mentioned at the beginning that that everything dark is basically hosted on GCP or Google Cloud Platform. Google Cloud PubSub is one of the tools we use on the GCP. In fact, it's one of the few tools that we use that's like, somewhat deep into GCP. That might be wrong. I'm not sure. We use a number of different tools for tracing or collecting data. We have OpenTelemetry. Really, we use a lot of OpenTelemetry and Honeycomb to instrument and to create different data. We do a lot of if we notice any problems in production or whatnot, Honeycomb's the place we go to, and so we have all these different extensions to make that happen. We connect to databases, specifically Postgres, and so NPG SQL is the tool that's used to connect to Postgres databases. We have some specific things for F# and Notatime around that. I don't know what Sodium is. And finally, we use a small tool called Argue to deal with command line interface arguments. I guess that wasn't finally because we do have this separate group here. I actually don't think that it needs to be in its own group anymore. But we use this NuGet package here to help us compile, to interact with the WASM compiled analysis portion of our backend. And we'll get to that in a little bit. So those are our dependencies, where there's quite a bit of them. Not every project, of course, uses each of these dependencies. Within specific projects, you will find a packet references file, which explicitly mentions which of those dependencies are pulled in per project. And anyway, so we'll look at those as we go through. And per project, I'll talk through what NuGet packages are used. And finally, in addition to this packet dependencies file, there is a packet.lock file. All this is for is ensuring that we stick to specific versions of each of these dependencies. So we don't accidentally pull, a new version of Expecto that is somehow incompatible with our code or something like that. That is what packet.lock is for. We forgot to close these, but we have covered these files, and we may close that section here. The next portion of the F# code that I want to go over is the general code baseline, basically the stuff you're going to find in any F# project, the stuff that oh, here's how we handle exceptions, here's how we handle testing at the variant base level. Really kind of boring stuff. I want to very briefly go over that. So we have a Prelude project. Prelude is basically like the stuff that goes before everything else. You see there's a README here. There's not really much to it, but it basically claims that it's similar to F#+. And we basically open it in all files, basically meaning that the functions that are available in Prelude.fs are available everywhere. The FS proj isn't really anything interesting. We're still in .NET 6. We restore these packet references, and there's just one file. That packet references, it's just a few things. We have some abstractions on top of ply, which is our async thing. Yeah, we have a number of dependencies. I won't go into each of these, at least for Prelude. But Prelude is basically one big file. It's like 2,000 lines right now. It should be broken down at some point. But this is where we set up a lot of kind of boring low-level stuff. For example, we have a helper function for isNull. We have various exception types that we define that we use throughout our code base. We have various functions that we use in creating or handling those exceptions. We have regex patterns that we use throughout, regex, active patterns that we use. We have a little function here to check whether something has been Blazor compiled or not. There's a number of tools we use for debugging purposes. Oh, what else? It's just kind of like a catch-all of things that you might find in any F# project. Base 64 stuff. I'm just really looking around to see if there's anything too interesting. Otherwise, I'll just scroll around. Don't see too much need to stick around here. Yeah, some node time extensions that help us out. Let's see, some RNG stuff. We use unsigned integer 64s a lot. So we have this GID function that we use to create a random one of those. Similarly, we have a random string. We have a number of extensions for strings. A number of extensions for maps or extra functions for maps and hash sets and dictionaries and lazy and whatnot. What else? JSON. This is a big one. It might be most of it. Most of the remaining. Let's see. JSON. Here's JSON. The big thing that's in here that I will skip over for now is that we have a serializer called Vanilla, which we use all over the place for serializing and deserializing. What's it called? Yeah, serializing and deserializing JSON data, data into JSON or from JSON. There's a whole section within this of running dark where we'll dive into serialization, so I'm not going to touch on that too much now. I mentioned earlier we pull in a NuGet package called tablecloth, which is similar to F#+. This here just extends that even further. There's this claim here that we'll later add them to tablecloth. I guess we should get around to that. Yeah, there's a number of different utility functions related to apply and tasks and just async work. And then there are some types that are just like so fundamental and used everywhere throughout our code that we define in Prelude. For example, a position, which is like what XY coordinate one of these things is at. That position is like such a basic type that we use it all over the place that we put it in Prelude. Similarly, canvas ID and user ID we use a lot. Usernames we use a lot. Org names we use a lot. Owner names, canvas name. There's all these just kind of names that we use all over the place. We have some HTTP header functions here. I'm actually kind of surprised that they are in Prelude or not in like web space or something, but they're here. And we have this function here that creates a UNID, an unsigned integer ID, from a normal one. We call it ID. I think that was kind of a mistake because that hides F# default ID function, which is like an identity function. But anyway, we define identity separately to deal with that. So that's Prelude. There's just a lot of kind of boilerplate stuff that we use to fill in the gaps that we think the standard library doesn't satisfy our needs. So that's Prelude. The next part of like general code baseline stuff, we have, of course, test for pretty much all of our source code. We have this separate folder here called tests, and inside that we have some utils that are used. Like any project, there are some Paket references. There's not too much here. We have Expecto, which is our testing framework. We have F# compiler service, which is interesting, but I'll get to in a little bit. And we have this thing, which again, I don't know what it is. So I'll click that for now. there's really only a few files within this project. It references a number of different projects, but we, but anyway, there's not too much going on here. The only thing I want to show off now is that we have a test utils module. This is used for all over the place for miscellaneous things. Just anything we might use in a test that is not specific to one test, we do it here. For example, we seed and clear canvas data a lot as part of tests. So we have a utility function to delete test data in a canvas. What else? There's just all kinds of boilerplate baseline stuff we use for tests, which aren't particularly interesting F# code, but you know, if it looks interesting to you, feel free to take a peek. Yeah, we have custom expects that we'll look into. Various custom equality functions. Some interesting numbers, some numbers that we might have issues with, and so we kind of keep a list around. For example, in interesting strings, we have some emojis, and interesting floats, we have max values, 0, infinity, and some irrational numbers, or mathy values, as we say. And anyway, so we have all these interesting values that we might use elsewhere. And that's really all that test utils is for. It's just functions and values that might be useful in various tests. But no reason to lurk there for too long. In addition to all these test utils that we use to support tests that we'll look at later, we also have a number of what I'll call utils in a project called Lib.Service. So this is, again, an F# project with a bunch of F# files here. And this is slightly more interesting. These are just common utilities for running an F# service as part of Dark. For now, I'm just going to cover the most boring parts of this, which include, of course, the fsproj, which isn't really at all interesting. It's just here are the files that are in it, and this is the order that they're compiled in. The packet references, which include mostly telemetry information, also some SQL information and whatnot, and also rollbar and honeycomb. Not too much to say there. But beyond that, there are things that are used a lot. So we have this config DSL, which is a tool that we use along with this config module to go from, what's this say, a stringified, what do I want to say here? Anyway, we have these two modules that basically go in hand, and these are to deal with different configuration values. If you were to look outside of the backend directory and into the config directory, you'll see that for local dev, I have all these different environment variables that are set for my local development needs. And of course, my file has been missing now. And those are referenced as part of config. So these two modules are used effectively just to pull different values from these environment configs. They might also pull some other things, but these are really used just to pull from these environment variables as far as I'm concerned. Similarly, not similarly, but I guess relevantly, we have a really tiny DB connection module, which is to wrap around some NPG SQL stuff, which basically just creates a connection string and a connection function so that we're able to connect to a Postgres database. There's not too much going on here. I think every F# project has some kind of DB connection module, maybe under a different name. We have an exception module. There's really not much going on here. We just extend the extension type, and we provide a re-raise function, which I guess adds a re-raise method to exception, since it's not normally possible to re-raise exception within F# continuous expressions, not continuous expressions, computation expressions. Cool, and that's it. There's not really too much going on there. Sometimes we want to run tasks in the background and kind of fire and forget about them. So we have a utility function for that. It is pretty thin. You give it a name and a task that needs to be done and basically thrown away, and we run the task. So we have some telemetry that is used to track whether, or to annotate whether the task is run successfully or not. We attempt to run the task. If it fails, then we roll bar it. Basically, we report an exception. But not too much going on there, just utility function. And something you'll see in effectively all of our F# services is we'll have an init module, and this is used to initialize what's ever needed to run the stuff in here. For example, lib service coordinates the connections to rollbar, which we'll touch on later. There's a rollbar module that I don't have here, but I have somewhere else. Anyway, so it coordinates the connection to that, and also initializes the connection to other telemetry, such as Honeycomb, and also provides a shutdown service. So this is a pattern you'll see through a lot of our F# code, is that we'll have this init module with sometimes just an init function, sometimes also a shutdown function. But not too much going on there. These are just the baseline. We'll get to the fun stuff soon. The last bit I'll go into as far as general code baseline goes will be the test projects, or the test project, and what that looks like. So I previously mentioned test utils, but now we'll go into tests. Tests is obviously a place where we have most of our F# tests. You'll see, everything from authorization to account stuff to queues to whatever. This is the place for those tests. Like any project, this has a packet references, mostly just testy stuff here, and also an fsproj, which pulls in all of the files in the correct order that we want to organize them in, and also all of the projects that are related here. So we test a lot of projects, so of course there's many references here. The first set of tests that we'll take a peek at are Prelude. So we define all those utility functions within Prelude. This module is just in charge of testing those. There's really not too much going on here. Some async tests, some canvas name tests. There's not too much. But we just make sure that Prelude is doing everything that it should. We have a test config file. This is used to pull environment variables for the sake of testing. These basically just leave us some integers of port numbers to reference. So when we run tests, we end up running all of the executables in the F# code as part of the test. For example, the built with Dark server is run locally so that we can run endpoints in the test and basically call them via an HTTP client and test those and all that kind of stuff. So the built with Dark server is run, and we have reference to that port. The API server is run, and we have reference to that port, and we have some HTTP client port. I'm actually not sure why this is needs to be a configuration setting, but we have it. And the final file that I want to look at as part of this is tests. This just rounds up all of our tests. So here are all the different modules with tests. In Expecto, they're not automatically found. You have to basically gather them explicitly. So it gathers the tests and it runs them. There's not too much it does here, but I'll take a quick peek. We open some modules. We init some serializers. We'll talk about serialization and the problems that go with that. We call libservice.init. That's the init function that I showed just a few minutes ago. And we call a number of other inits that basically ready us for being able to use different parts of our code. What do we do then? And then basically we run Built with Dark will run. Oh, this isn't where we run Built with Dark. I forget what I was going to do. But in any case, we do a bunch of initializations, and then we run the tests. So here's that test list up there, and then we run the test. So in case you're curious what it looks like to run a Dark test, I'm going to cd out of here into my normal Dark clone of the repository or instance of the repository, whatever you want to call that. And I'm going to, first off, get inside of the Docker container that the development environment is run on. None of this is really happening against my local machine. It's all in a Docker container on my machine. So I am accessing that machine, and what I'll do here is, well, first off, I have all of those files available to me, the backend, the client, whatever, is I will run backend tests. Anyway, I just wanted to point out that this is the thing that triggers these tests being run. So this run test with CLI args is this. I can either just run all the tests like it's currently doing. Apparently I have a failure right now. Maybe it's some flaky thing. But what I could also do is I could say filter test list to just test dealing with, I don't know, lists. Since we have we support lists as a language feature, and of course we have at least 234 tests that are passing related to that. So anyway, that's what the test projects is for, and we will go into the many tests as we go through some specific sections. So that is the general code baseline stuff. From this point forward, it should be more interesting. We should be able to actually look at some Dark specific things and get to the fun stuff. All right, finally we can get to the part of Dark's F# source code, which I think is the most interesting, or at least the most interesting to me. I come from traditional line of business application, collect data from users, put it on a pretty form, save it, return it later in a different format, blah, blah, blah. Very much like line of business web applications for either small startups where they're trying to build like a web app, or for established companies that they're trying to grow something existing. And so there's been very little kind of low level work. With Dark, that's not the case, because there's a lot of interesting interpreter work and language work and that kind of thing. And that's what we're going to start touching on now. So we can talk through first the implementation of the Dark language, which is most of this project called Lib.Execution. And then that covers the actual language definition and the interpreter. And then we can cover the standard library, basically the functions like, add, adding two numbers or two floats or something like that. Those are all defined in standard library. And then we can talk through how we test that. I think we have a pretty interesting way of testing Dark code anyway, I won't spoil anything, but we'll get there, and I think it's pretty interesting. So this section here is probably going to be the heftiest, and then a lot of these sections later on I'll go through more quickly. So Lib.Execution is a project under the backend source directory. So Lib.Execution, and it's got, I don't know, a dozen or so F# files. Actually, I'm not sure why I'm not viewing it in F# mode. That's why. I'm not sure what's broken. Ooh, I think I broke an SLN. So I broke the solution file, so I will look at it in Explorer mode. I will make a mental note to fix that. Anyway, so we have this project here, and let's just go through it. We have a Lib.Execution FS proj. Like everything else, this is pretty simple. I think these code comments are garbage, so I would ignore those. At least they're not at the right location, certainly. The only project that's referenced here is Prelude, so we don't have any, lib service utils or anything like that. We just have Lib.Execution. This is the basically the base of all of Dark's code is this. And I'm going to just go through these files in order, at least roughly in order here, and go through them. The most interesting stuff will probably in runtime types, interpreter, and program types, but I'll go through all of it at least briefly to get a general overview of what's happening and how it's built. So the first file is vendor tablecloth. I mentioned earlier that tablecloth is a NuGet package that we bring in that provides a baseline of functionality for, like, you know, extra map functions, extra dictionary functions, etc. Vendor tablecloth is, I think it's just further extensions from that, or maybe it's a copy of that. I forget. Maybe it's a copy, like a limited copy, but it's really a boring list of additional functions where, trying to think of a good example, like tuple2, we have a function to grab the second element from a tuple of 2 elements. We have a function to split strings, drop the rightmost character on strings, list functions, blah, blah, blah. So not too much here, really baseline. Oh yeah, we do have a packet references file that I did not cover. There's not much in here. There's some async work through Ply, and there's some Newtonsoft JSON for serialization to JSON. Again, we're limiting that more and more. I'm curious how much of this is still actually in this project. And we have F# plus and we have F# core. I don't see tablecloth here, which indicates to me that we're not actually pulling that NuGet package in for this project, and that vendor tablecloth is really a clone, just to make sure that we can't break anything. The Lib.Execution very specifically does not have dependencies, because if something in here breaks, then pretty much everything breaks, because if the interpreter breaks, then everything that's based on that will not do so hot. So that's it for packet references and vendor tablecloth. The next two files, and I want to make sure, I do them in order here, are runtime types and runtime types AST. So there is an idea of a program type, which is the code that exists as you see it in the editor. So these all represented in program types, and if you like, if you go to settings in Dark and then go to contributing and then show debugger options, you're able to actually see, oh, I'm zoomed in too much. We're not great at dealing with the unzoomed in page, but I'm able to view the AST of my Dark code in the editor here. This is not a great representation of it. We certainly need to improve this page, but you see here that there's a representation of this code. So this is a program in program types. But when you're executing them or you're running them, a different set of types is used. So anyway, we'll look into the difference between those in a bit, but just know that there are two different entities. Runtime types, which are the things we actually evaluate, and program types, which are, as you see here, converted to runtime types, or simplified into runtime types, I like to think. But without any further ado, runtime types. I'll scroll to the very top. This is a long file. It's 1,000 lines. These are the core types and functions used by the Dark programming language runtime. These are not identical to serialized types, as those have unique constraints, but these are the types used in runtime. So let's just scroll down bit by bit. So first off, we have an idea of a fully qualified function name. Actually, I will fully qualified function name, which can be one of three things right now: either a user function, a function that a user defines themselves, a standard library function. Again, this is one of the functions that we just shipped, or a package function. And we don't have a great package ecosystem right now, but we do have some packages, and these have their own different naming criteria. For example, a user function is just a string. If I were to go here, in fact, apparently I do have a function called fn96 blah, blah, blah. This function name corresponds directly to this function name here. We also have standard library functions, which exist in a module, have a function name, and have a version. And there are package functions with more details. And then within that module, this fully qualified function name module, there are a number of different helper functions to determine certain things about. For example, is this a database query function? We have a helper around that. Is it an internal function? Blah, blah, blah. So we have this fully qualified function name module. We also have a thing called a dDateTime, which is a dark date time. This is just this. It's basically a dark date time is always just a node time local date time within UTC. That is our construct for dates. And we have a number of functions to help us around that. And then here's where we get to the actual language part. We have the idea of an expression. Actually, let me focus on expression for a bit. So an expression is just a little bit of code that is dark. So integer, you can imagine that is literally just this, right? This is an expression that should evaluate to 1, the integer 1. And so we have the integer. So we have the integer value here, and we also have an identifier. For each of the little bits of dark that you have in your code, we have the actual expression itself, and we also have an identifier that references it, and that's useful in a number of different ways. So we have really kind of boring types. We have an integer, which is just a wrapper around an int64. We have a boolean, which is just a wrapper around bool, a string, wrapper around string, etc. There is a concept of a blank. So if I don't fill in some bit of code, this is a blank. We do certain things with that. We interpret it in certain ways. We do have a null for now. That will be gone. We have characters, floats, null, string. We have let bindings. So this here is the equivalent to, so if this, let me think how to put this. If I had an object of let str, let's see, int1, variable str. It's a little bit hacky here, but here, I'll make this foo instead of str. So this is a really quick kind of BS expression, basically saying, hey, here is a let binding where we're binding the value 1 to foo, and then the final expression that's used in this binding is the body in which it's being used here. So we have let foo equals 1, and then foo. So we actually reference that. I think e-variable is the right thing. So e-variable, e-variables. This is a reference to some local variable. So we have the let bindings. We have if expressions. The system here is that this is the condition expression. It should return true or false. This is what should be returned if it returns true, and this is what should be returned if it returns false, or if it resolves to false. There are field access, there are lambdas, lists, tuples, records, constructors, match expressions, feature flags. So there's a bunch of different parts to this runtime language. The last one that I'll kind of dive into here is the match expression. A match expression, just because it's a little bit more interesting. Let's say have match just one. Yes, I don't know, not feeling very creative, but this is an expression which has one kind of argument, one input. I could extract this to an argument here and put this in normally. Oops, I got that into a funny place. It has one argument and multiple patterns, or sorry, multiple cases that it'll evaluate against. In a match expression, of course, if you're used to F#, you know that the first pattern on the left that matches the condition or matches the expression will be used to determine which right-hand side arrow or which case we actually evaluate here. So let's see here. Let's make this a little bit more complicated. If I want this to be, let's say if it's nothing, we just say nothing. If I say just one, then I'll say one, just something else. I can do something else or whatever. Let's see. So I can create this expression here, and these are the different cases, and the first one is a nothing. It doesn't match that. First one it does match, and you can see it's actually highlighted here in the editor, and it does that. Otherwise, I can do a catch-all. So these patterns on the left aren't just for static values. They can also be used to capture some specific values. So I can use this one elsewhere. So that's what a match expression is. It's the argument and then all the cases. And each of these cases on the left, in terms of what we match against, are called match patterns. We can match against explicit booleans or strings or floats or tuples or whatnot, or non-concrete values such as a variable. This is something that should be expanded long-term a little bit, but that's how it works right now. So this is a runtime expression. This is, when you're thinking of code, you're often be thinking of runtime expressions. In reality, you're typing program type expressions, but we'll get to that in a bit. So that's an expression. I'm not going to go too deep into the Rail aspect of Dark. Dark has this feature where you're able to, what's something that might return an error? Yeah, list head or something like that. So let's say I have this empty list. Right now, the code is not making me, or the editor is not making me handle the case of a non-empty list. But you see an evaluation here, I'm seeing this like error nothing and blah, blah, blah. So what I could do is I could take this function off of the rail. And the way I can do that is, how do I do that? I always forget I thought I could do it over here. I forget exactly how it works. Maybe it's Control-K, Control-S. I forget exactly how you do that. But the point is you can get to the point where it'll refactor this code to force you to deal with the error. And so we have this thing called the error rail, which basically allows you to choose whether you want to deal with error cases or not, which help with really quick prototyping and such. We have pipe expressions, so you can take, or we have pipes, so you can take some value and pipe it into some other function or something. So there's some constructs around whether we are in a pipe or not in a pipe. I already covered match expressions. I'm going to skip over a number of things here, but we have HTTP responses. So if you do create a HTTP handler, it can, what do I want to say here? You can either return a value or you can return redirect here. So I could say, oh, well, depending on the certain circumstances, I can return a redirect to some other URL. That's a construct here in the runtime types currently. So those are like the, up here, the expressions that make up the language, and then there are also values to consider. So when an expression has been interpreted or evaluated, the result is contained within this thing called a deval or dark value. These dark values can be really boring, like an integer or a float or a bool or a null or whatever. They can be of some compound type, like a tuple or a list. They can be an error or an incomplete, basically usually reflects on blank, like if it's trying to if this is your whole program here, this is going to resolve to be an incomplete as you haven't completed the program. And there's some other return types as well. You can return some kind of HTTP response. You can return a reference to a data store. So you see here, I have a data store called blog. I can reference that directly in code. That pans out to be a DDB reference here. So I'm just referencing a data store. Of course, dates, passwords are a thing. They're basically like masked. They're basically the secrets you saw here, this mailinator. They're just ways to mask certain kinds of data. So there's that. UUID, options, results, and dbytes. So those are the dark values. These are the things that a dark expression can result in throughout the code. And finally, we have dark types, and these are like, let's say I have a user function here, and I want to have a type assigned to it that I know it's going to return a string. Dark types are effectively, what type system exists within dark, and what does that look like? So, any function can take in an int if it assigns itself to, or a string, or a tuple, or whatever. These are the types. This is the type system that's in dark. So we have to think about the values, the expressions, and the types. These are three separate constructs, although they're all interconnected. And we have some helper functions around here with types. All right, let's see. We have made it only a third way down this file. Yeah, the rest of this isn't too interesting. I'm going to skip over a little bit. We have some functions to help us, extract the ID out of an expression or match pattern. So this just matches against the expression and pulls out the first part. Same thing for match pattern. We reference these by identifier relatively frequently. We have a number of functions within a deval module to help us deal with those. So fake values are like, obviously not real values. So a dint is a real value in the sense that it's a real, it's a concrete thing you can pass around, but an error or an incomplete or an error rail are not necessarily useful things. So we call those fake values. Number of different helpers there to type. Oh yeah, so this will, from a dark value, determine what the runtime type is. You can see how that is. I'm not gonna stare at that for too long. And relevant to that, you can verify whether or not some type match has passed. For example, if I claim that this here returns a string, but I return a 1, there's going to be a type error saying, hey, you told me you were going to return a string, but you returned an int. That is powered by this type matches function or something similar to it somewhere else. What else is interesting here? Oh yeah. In addition to the language itself, the runtime types also hosts information about other core constructs, like not necessarily relevant to the language itself. For example, the interval at which a cron can be set is here. So we have daily, weekly, etc. Those cases are here. We have the construct of a handler, which is, again, anything that can handle dark code. That can be either an HTTP endpoint, it can be a worker, it can be some old worker thing that we're still supporting, but you won't ever see. It can be a cron, it can be a REPL, etc. And so that's the spec. And so any handler, any one of these top level things I can drag around, is represented as this record, a top level identifier, TLID, the AST of the code itself, and the spec, or the kind of blueprint of what type of handler it is. So all the pieces of your dark program are eventually going to be basically these handlers. What else do I want to get at? Oh yeah, so in addition to handlers, we also have data stores. So we have, here's a data store. It has a title and it has a variable number of fields and types corresponding to it. So naturally we have a column type with a, the column name and the type corresponding to it. And we have a data store, which is again is the top level identifier, the name of the data store, and the list of columns or fields, and then also the version of the data store. I'll breeze by some of these other ones if you want. Feel free to poke around, but we have user types with their own definition, user functions with their own definition. A top level is pretty much anything that you might see on this canvas, including handlers and databases and whatever. Literally, it can be either a handler or a data store or a function or a type. Those are the top level things of your program. There are also secrets. I mentioned user secrets. There's really not much to it. There's a name and a string. And the last few things to domain model, we have a package. So alongside here on the left, you'll see this little package icon with these mostly HTTP client packages. Those look like this in the code. Not sure what to say there. Each function, like each standard library function that we'll see, has the concept of previewability to it or purity to it. We'll look to see how that plays out in a bit, but it basically determines whether or not the editor is able to evaluate the function totally within itself, or if it needs to reach out to the backend, to Dark's backend, to do some evaluation. For example, 1 + 2, the editor has no problem evaluating that perfectly because the addition operator is a pure function, but HTTP client get to my website is not something, it's not something that's able to return automatically. I have to explicitly call out to some external resource, or I have to call it to the backend to call it to external resource. So there's this concept of previewability or purity that's managed here, and we'll see a lot of reference to that. Functions can be deprecated. Just a second ago, I was typing HTTP client get, and you might have seen two different versions of this. The v5 and the v4 here. v4 is deprecated at this point. You see here, deprecated replaced by v5. So we have that concept. Oh, we gotta fix this little thing. We have that concept in Dark, and deprecated functions are not available to you in the editor unless you already have a usage of them somewhere. So somewhere on this canvas I have v4 referenced. You see I don't have v3 or v2 or v0 or whatever referenced currently. Along with the function being deprecated, or sorry, along with so deprecation can be one of four cases. It can be either not deprecated, which is true of probably most functions, or at least all the functions that you see. We can add a note that it's been renamed to something else or replaced by something else, or just fully deprecated because of some reason. Okay, there are a number of functions that can or cannot be used, or sorry, there are a number of functions that can be used in a SQL, in a database query. So we have this idea of a data store, right? You saw this blog data store. And early on, I fetched the records from that via a getAll function. But we also have dbQuery, which allows you to reference a data store and then only fetch the values that pass certain criteria. So, for example, here I'm just going to say true because I want all of them. But I could do, let's say, value.title let's say string starts with about contains first. I don't know. I'm making stuff up to kind of capture the case, but you see here that there are certain things I can, certain functions that I can use within a dark expression, and they're properly resolved to SQL under the hood, but there are also some things that can't. For example, if I started to try to make an HTTP client call here, it just wouldn't let me. So anyway, we have various metadata around whether or not a function can be compiled into SQL and how that would work. Okay, really towards the end, yeah, we have different ideas of functions, built-in functions. I don't think there's anything else here too much that I want to get into. I'm kind of running out of steam on runtime types. Yeah, so there's not too much more happening there, but you get the point that we have these different constructs for expressions and values and types and whatnot, and these are all kind of reflected there. So that's runtime types. Quite a bit. The next module we have is much thinner. It's called runtime types AST. I think it's just, yeah, it's just two functions, post-traversal and pre-traversal. The short version of these is that they recursively dive into your expression to do something, which becomes useful in various settings. The next piece here are errors. Errors are just reusable error messages in the standard library. You know, we face certain kinds of errors pretty often, such as like type checking errors or you know, different kinds of runtime errors. And so we have this module to provide functions that we can quickly report on those errors, or quickly raise those errors rather. I'm not going to spend too much time there. There is a type checker, which is thin, which, as you could expect, checks the type of things. So here we have a function called unify, where we take in all user types that exist within someone's canvas, some expected type, and some actual dark value, and we confirm whether or not the value matches the type. Not too much to say here. It's basically like the other function we saw, I believe. And we have other functions in the space of checking type. I don't think these are worth diving in too much. The next big thing is the interpreter. It is pretty big. It's like 800 lines of code. And so this is the thing that what do I want to say here? That takes the runtime types, or so the runtime expression, basically your Dart code whatever you write here, and interprets it and tries to get a value out of it. And so the main function here is this function called eval. This is probably the only thing I'll really look at here. And eval is in charge of taking your expression and getting the result of it. So if your whole AST, your whole code was just a blank like this, then the result of that will be that you have an incomplete program. That's going to be the result of it. If, on the other hand, your whole program is a Boolean, like true, the result of the whole expression will be that corresponding Boolean. So you see here, we're mapping from the expression form of Boolean to the value of Boolean while ignoring the identifier. So we're going from expression to deval, or dark value. And of course, you have something more complicated like a let binding that we would evaluate the right-hand side of the let expression. So if I had let a equals 1 plus 2 in A, what this will do is it'll take the right-hand side of that expression, the thing after the equal sign, it'll evaluate that, and it'll use that value in determining and basically evaluating the rest of the stuff, whatever's on the body side of the expression. I won't go into all of this interpreter stuff itself. I think this is totally worth a read. By itself is kind of how I got into Dark, is just reading through this. So I would recommend that if you were interested in this kind of stuff. There's a lot of stuff going on here, checking if match patterns pass, that kind of thing. Yeah, here's how if expressions are dealt with, etc. I'm skipping over probably a lot of important pieces. For example, if I'm skipping over them, I might as well skip over them, so ignore where I was about to go. But we have this interpreter. It turns expressions into values. What else do I want to say here? Yeah, these are all just different ways to call, to request an evaluation for some expressions. So I don't think these other things are worth going into too much. So I will call that for the interpreter. Let's see here. We have the concept of analysis types. These are types that are used in going from an expression and previous inputs, previous playthroughs, and the results here. So earlier, I showed you that, where is the thing? I keep on creating, here's a case. I showed you earlier that HTTP endpoints can have a number of different traces built up over time as the HTTP endpoints are called into, and that we have this data to us later. The process of taking the current Dart code or maybe past Dart code and these traces and turning it into something I can debug and analyze is something we call analysis. And there are some specific types that are defined to be used in that process. So there are, what was used when we called some specific function, what are the results of a whole trace? So for example, what was the return value of this whole expression for this dot, or for this trace rather, etc. So these types are really just kind of building up some infrastructure to allow us to do some analysis later. There is a module called execution. I believe execution basically just gathers the state necessary, or the pieces of data necessary to call the interpreter, or to evaluate some Dart code. There's not too much to talk about here. And the final bits of fun within source Lib.Execution are with program types, and turning those program types into runtime types. And so the first thing I should probably do, actually, let me make sure I get the order of these right. Yeah, so it's program types, then parser, then AST, then this. So I got those right. So the first thing we do is look at program types. You'll see here that this is much thinner than the runtime types. There's not as much program type specific stuff happening, but you'll see very similar things to what we saw there. So there is a fully qualified function name. There are match patterns. There's an expression. There are types. There are the same handlers that we saw before. There's the database, user types, user function, top level, etc. And there are also ops. I'll talk about ops in a second. So these are effectively, they should feel pretty similar to the runtime types, and they are. The program types just might have a little bit extra to them, or a little bit more data that gets erased when we translate things to the runtime types. For example, trying to think of a good for example here. Probably bin op here. Do we have a bin op? No, just the SQL bin op. Okay, so in program types, we have this idea of a binary operation, where it's just basically this infix operator with a thing to the left and a thing to the right. that gets erased during translation between program type and runtime type. The bin op doesn't need to exist in runtime types. And the thinner runtime types are, the easier the interpreter can be. If that didn't quite make sense, that's fine. But these are effectively a copy paste of the runtime types, but they can have a little bit more to them. The only additional major thing that program types has that runtime types doesn't is that when you're working with a program, you have to worry about how you manipulate that program, whether it's setting the code to one of these handlers or to create a new handler altogether. These ops or operations are basically all the ways in which you can set, or not set, but update a Dark program. That's not quite true, but it's close enough. You can set a handler. You can do a number of different things with your user databases. You can delete a top level or any of these kind of things that are floating around. You can delete at any point. There are more database things. You can undo, redo. Dark has infinite undo, redo, where if I hit Control Z, it'll start undoing my operations here. I don't know why when I'm doing Control Shift C, I'm getting an add ops problem. I should probably check that out. Might have discovered a bug there. Oops, where am I? You can set some expression, etc. So these are all the different things you can do to your Dark program. If you have multiple of these, let's say you just typed a bunch of things in a row and done a bunch of actions, we have these in a list. We call that an op list. And the rest of these are the same as runtime types. The next thing here is the program type parser. What is going on here? Okay, so this, what does this do? Provides toString and fromString functions for program types. Okay, so this isn't used most of the time. Most of the time, we store programs in like a binary format, which we'll touch on later. But this is a way that we use to basically compile. Actually, I don't even know. What do we use this for? How about this? I'm going to skip over this. I don't know what this does. It sounds like it's not going to be a thing going forward, so I will ignore it for now. Program types AST is probably very similar to that runtime types AST. This just provides us some functions to traverse or dive into program types, specifically expressions, it looks like, maybe map patterns, etc. So this might be useful in a case where I have a Dark program and I want to find, let's say, all the if conditions within that Dark program. I don't know why, but if I wanted to, what I could do is I could pass a function in here to explore and to explore the function and come up with some result. Maybe that's not the real use case, but you get the point, is that sometimes you need to traverse to try to find something or to map something from one of these instances to another. And the final thing, or take a brief break, is the program types to runtime types. This is the thing that basically thins out program types into runtime types. Runtime types are a little bit thinner than program types, and this is the thing that that does that work of thinning things down. And so for each of those types, we have a module that will do it to RT or to runtime. And we don't need to go the other directions. There's only two RT. All right, so that's a quick long overview of Lib.Execution. It is the core of Dark. It's how the language works. All the other stuff is kind of built around it. So, but that gives us a point where we can check this off, which is satisfying and tiring at the same time. The next section here is going to be much easier to cover, and that is Lib.Execution standard lib. These are where our all of our standard library functions exist if they can be run if they can be run on the client safely. So let me go to that project, which is just below, and I'll do my normal thing. I'll look at fsproj first. As you see here, these are all like kind of boring types. There's floats and dates and whatnot. You do see a little bit of stuff that looks like it might not fit, like HTTP and HTTP client, but we'll get to why those do fit. But in any case, we just pull in Prelude and Lib.Execution, which is the frameworky stuff. And a lot of these files, or pretty much all these files, consist of just a bunch of functions. This is currently what a standard library function looks like if it's written in F#. It contains a number of things. It contains a name, which involves the module that it's in, the name of the function itself, and the version of the function. It contains a bunch of parameters. Either 0 or more parameters that you take in as arguments, the type that you expect to return, a description of the function in a kind of pretty document format, the implementation of the function itself. This is a really kind of boring implementation where we just, it's a bool not function, so it's literally just going to do bool not. Some details of whether or not it can be used in a SQL function. This is used when we do that DB query thing, where we basically compile your Dart code to SQL. Some notes of whether the function is pure or not, or whether it can be previewable. And some final notes on whether or not it is deprecated. So this function here, in its definition, is what allows us to do a bool not, right? Bool not of true is false, and false is true. That is powered by this function. And so all these modules are basically in charge of just doing that, of just providing many different little functions. So we have bool not, bool and, bool or, bool zor, is null, whatever. One thing I forgot to mention is that the pretty description thing is what powers this. So we have a certain kind of string formatting that allows us to create this pretty character, or this pretty description here. So we have all these different definitions. Some of the modules only have a few functions in it. For example, bytes, I think, only has a few functions, although they are, heftier than the bool functions. Char has a few functions, etc. I'm not going to go into every single one of these and like read you the functions in the standard library because that's kind of useless. But this is how we deal with the implementation of Dark's standard library. They're all in just these libx files. So you can imagine really boring implementation of bool, bytes, char, date, dictionaries, floats, ints, list, some basic mathy stuff like cosine. Lib.no module is slightly interesting. It basically just means that this doesn't exist in a module per se, like a toString function that can just be used everywhere. That isn't really have this part to it, doesn't have a module to it. Those all exist here. That includes toString, toREPL, equals. So I think you can either use the equals function or you can use the equals operator. Those are here. Not equals, similarly enough. ToForm, I'm not sure what that deals with. It seems like some HTML thing. For demonstration only, it seems, yep, we have deprecated. I was just about to say we should. And I'm not sure why these are in the Lib.no module, but we have some kind of like miscellaneous functions also in here, such as AWS URL encode and Twitter URL encode. So there's a number of like pure functions here that exist in no module space. We have lib.object, option, result, string, UUID, tuple 2, and tuple 3. Again, feel free to poke around those implementations. There's not like a ton of interesting stuff there. I do want to touch on Lib.HTTP and some of these other ones because they're a little bit funny sitting in here. I'll start with Lib.HTTP. This is, what does this do? Okay, this just takes in a some value, any dark value, and an integer for the status code, and it basically just wraps it in a status code and value. So this is a pure function that allows you to do HTTP, what was the name of the function? Response. So you take in some input or some response body and say it's 200 okay, or whatever you want it to be. And this is more relevant in a an HTTP binding here, HTTP endpoint rather. So this just happens to exist in here because it's a pure function, even though it's kind of not as core as maybe a char or a bool or something like that. What does Lib.json do? Oh, this is an old, yeah, these are just old ways of reading and writing dark values as JSON. Can I even still? Yeah, I can parse this. Let's say I want to do, I don't know. Can I do this? I haven't really used this function much. Expected start of string. I'm not sure what this is upset about, but you get the point. This is trying to parse some stringified thing as dark. I bet it's because I'm not using single quotes there. So anyway, these are pure functions. These are available, and these are in here as well. So we have that, and we also have the std.lib file, which gathers these all together. So this is basically a list of functions. I mean, that's what this file is. In addition to just being a gathering of all these functions, it also provides us with a number of different renames and like duplicate names that are allowed. For example, list contains can also be referred to as list member. We used to call, I forget which way it is now, whether this is the new function or this is the new function, but at some point we renamed either to or from string.toUUID, to or from UUID parse. Oh, it says here old name, new name. So we renamed from this to this. So we have a system of basically having or allowing duplicate functions via this little handy map. We also provide infix functions, so you can call int add either in the prefix way, like 1 plus 2. Oh, I hate when I do this. I'll just create a new REPL. Where I can call 1 plus 2 this way in the prefix format, or by the power of this little line of code here, I could also call just the plus operator. So these exist for a number of different types and such. So that's what std.libfs does here, is it just gathers all these. So these are like the standard library functions that are used pretty much everywhere. I didn't look at the packet references. There's really not much interesting happening here anyway. But that is pretty much all of Lib.Execution standard lib. I did skip some HTTP client stuff that I'll circle back to later. So that's the implementation. But of course, all of this needs to be tested. And so we have some, I think, interesting ways of testing the execution itself, the interpreter, those standard library functions, etc. So I'm going to take a quick peek at some tests to go over that. So first off, we have RT shortcuts. These we don't really even use them that much. They're basically little shortcuts that way you can use in tests to create expressions quickly. For example, I don't want to type out e-integer gid int64i. I can just type eint and then the integer, and it'll create an ID for me and such. So you can imagine in tests, I want to create a lot of runtime values quickly. This is just a bag of helpers to that end. Next up, we have runtime tests, runtime types.tests. And there's some tests around here. I actually don't think there's too much interesting going on for the runtime tests and probably not for the program time tests, so I'll skip over them. What's happening here? Oh, this is some parsing. It tests the conversion between program types and runtime types. That is kind of interesting, but I'm not going to dive into it. Whatever. There's a number of different tests here. Lib.Execution is actually, I'll get to Lib.Execution in just a second. First off, I'm going to look at type checker tests. Just to knock this out of the way, this just ensures that our type checking works as expected. Again, we use expecto for like everything in our tests. But the really interesting stuff, I think, comes in with these three files here: F# to expression, the tests of that, and then Lib.Execution tests. So we test a lot of Dark functionality via test files in this directory right here. I'll go to bool.tests. And you can see here the directory. This is in backend test files, execution, and then bool.tests. Each line here is a separate test in that we parse as F# and then convert to Dark and then execute in Dark. So we had this test, for example, checks to see that false and false equals false, that passes. True and false equals false, that passes. However, true or false equals true, that's true. So we have all these like one-liner tests here that we parse into F#, parse as F#, and then convert to Dark expressions. And the way we do that is we have a function here called F# to expression. And this uses F# compiler services, which is a NuGet package readily available to parse the program via this function and then to convert it to a Dark expression. And there's a lot of stuff happening here that I won't dive into, but I'll start here at just the tuple conversion. So this is like how F# looks at F#, and it has a number of different fields. It has a first part. Oh, how do I even go into this? Oh, you know what? I'm going to convert pattern. I don't want to do that, do I? No. Let's dive into something easier. So let's say that the F# compiler is looking at this specific line. What it'll do is we will take this text, we will pass it into parse, and we will get a syn expressor back, which I think is like syntax expression. And this is basically an abstract syntax tree of all of your F# code. And what we do then is we take that syn expression and we want to produce a program time expression from that. PT is program type. And so it'll look at this and it'll say, okay, well, what is this? What's the type of this thing? Is it, if it's null in F# land, it should be null in Darkland. If it's a Boolean in F# land, then it should be a Boolean in Darkland. I'm not sure if I said that right, but you get the point. It converts from these F# types to dark types. Sometimes they're really easy, like Booleans. This is the only line of code probably in this file that deals with Boolean conversions. But other times it gets more complicated. I think that, if you get in a dark, this file itself is worth reading, but it does take a little bit of background in F# compiler services, so it's probably best to start there. So anyway, we have a bunch of test files. You see in this execution folder, we have a bunch of tests for bools, a bunch of tests for dates, etc. And so we have this file here that does the conversions, this file here that does the testing of those conversions, and Lib.Execution is the guy that basically uses this, or is one of the pieces of our code that use it. So it will, let's see if I can find this. Okay, so we have a directory named, that's where all these test files are, and this test file, this F# test file, gathers all of the files in that directory with the suffix of .tests or with the extension of tests. I don't think we need to explicitly filter these out, but whatever. So it filters those out and it runs the tests. I'm not going to dive into exactly how it runs the tests. There's a lot of setup involved and whatnot, but the test cases are gathered and as part of and they're run as part of the regular backend tests. So we do have normal F# tests, but the majority of our tests are written in these .tests files that allow us to just write a test in one line of code without having to wait for compilation step or something like that. So I think that's really neat. That takes care of this, and it also takes care of this. That's a lot. That's how we test some of our internal stuff there. I probably should have mentioned this earlier, but we do have some functions that are available to test, some dark functions that are available to tests in these .tests files, but not available in normal day-to-day work. For example, if I went into dark here and I did test : blah, 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 I wouldn't find error rail value. But it turns out that in a number of cases, it's nice to be able to kind of inject certain values into these test cases via this. So for example, test infinity is used in a number of different float tests to check to see, hey, is the negative of infinity negative infinity? That's a good test case. And anyway, this just allows us to have a quick way of injecting that into these test cases. And there's a bunch of different test-specific dark functions that are all defined here in libtest. Let's see what's an execution test. What is an execution test? In each of these cases, if I don't know what's in one of these files, the best thing to do is probably scroll to the very bottom where the test list will be seen. Yeah, these just look like extra language things that we're testing that couldn't be easily tested in the individual test files. I'll just focus on list literals, blanket and list evaluates incomplete. I'm not sure why that couldn't be in a normal test file, but that's basically saying that if I have a blank expression, it should return incomplete. Easy enough. I skipped over a piece here in test files. Back in the test files directory, you'll see a bunch of subdirectories or just a few subdirectories. You'll see execution, which is the thing we just saw. That is what the Lib.Execution.tests.fs covers, is all of these tests. There's also a data folder. This is used for binary data that that might get messed up if it was just like try to like copy paste. I'm trying to think how to put this. This is basically just a holding ground for different pieces of data that we use in tests. That's really all it is. And here we have some boring text, but we can also include images and all that kind of stuff. So we can test whether we're able to handle, non-text HTTP bodies, for example. And then there's, of course, a fairly extensive README about how all these tests work, including the execution tests and whatnot. And the final thing regarding the baseline implementation of language and standard library is std_test.lib or std_lib.test, and that is this is really just another. Actually, what is this? I thought this was something else. Okay, this is another thing, I guess similar to execution tests, where we couldn't quite test certain things ergonomically within those thin test files. So these are hard to represent tests. I'm not going to dive into those. Okay, so that covers the core of Dark, the language. We've gone over the implementation, the standard library, and how we do a lot of testing. That should be the longest section to talk about within all of Dark's F# code. The next piece to consider is the fact that although that covers the language itself and some of the high-level details around like handlers and data stores and not, it really just did a very minor amount of domain modeling for, let's say, handlers, and it doesn't do the bulk of the work. Lib backend does a fair amount of the work of modeling the backend of Dark beyond the language. And so the next thing we'll do is we'll take a peek at that. It's not very interesting. It's not true. It's not maybe as compelling as the standard library stuff, but I think it's still certainly worth going through. So back in source, I'll go to lib backend and I'll start at the README. So lib backend is the core of the backend application around Dark, everything from user management, web servers, logging, etc. So it handles like the backend besides the language stuff. There's not too much to say there. There are a number of packages that are pulled in here. There's some Postgres stuff. There is a reference to pusher server, which we'll take a peek at. Some regex stuff, etc. And finally, the FS proj. Not much interesting here. We pull in Prelude. We pull in Lib.Execution. And we pull in two projects that we have not yet looked in. Actually, no, we have looked at libservice. That just provides, again, just really kind of boring, low-level stuff, like database connections, etc. Lib binary serialization we have not talked about. I will cover that towards the very end when I go into serialization in Dark. But there are a bunch of files in here, so we can take a peek at this. I'm not going to cover all of the lib backend as part of this section here. We'll circle back later on. Anyway, that checks off these three. The first thing we'll look at here is just some config. This also, I don't think this is really particularly interesting to Dark. This is just a file where we pull environment variables and their values to use in Dark. File fs, very similarly, this just provides a bunch of functions to read and write to disks on file. I think most F# applications would include that. NDB, similar to the lib service stuff. This is kind of boring. This just provides us some functions to query databases and to write to databases, etc. We do this with NPG SQL. We don't have like Dapper or any kind of ORM in between. They're just kind of raw SQL. That's pretty much there. We then start to hit on some Dart specific stuff. We have a concept of a canvas. This is a canvas. A canvas is like this big scrollable thing in which we have all these handlers and top levels and whatnot. And so this is where we start to manage a canvas. Of course, the baseline construct of a canvas has already been defined. We actually saw that in Prelude. A canvas has a name. It has actually, it doesn't really have much. It has a name and it has all its handlers. And this provides some functionality of storing and fetching canvases from our Postgres tables. So this gets a canvas ID for a canvas name. For example, my canvas name here is stashu-demo. This will grab some UUID that corresponds to it in case I want to rename the canvas or something like that. It's best for the canvases to be stored via identifier, or at least to have an identifier. I won't go into all these functions, but you can imagine that all of these are basically fetching and not all these, but all the functions up here are fetching information about canvases there. This is a construct of a canvas. It includes a number of things. Oh yeah, so Prelude only involved a canvas name. It didn't define a canvas. Canvases include a number of things. It involves some metadata, which is just the canvas ID, the name of the canvas, and who owns it. It includes all the handlers to that canvas. So your HTTP handlers, your crons, your workers, the data stores that you've defined and put data into, your functions that you've defined, any types that you've defined, and a bunch of deleted stuff. Whatever you might have had before, but you've deleted explicitly in the UI somewhere. As well as some secrets. I guess these should be probably up there. So there is this module. We also have helper functions to work with, or sorry, that's the type. We also have a number of functions to manipulate these canvases, to add top levels, to delete top levels, etc. I don't think there's too much to say down here. Previously, when we were talking about program types, we touched on the idea of an op or an operation. These are all the things that you can do to affect a program or a canvas. This is the part where we actually do something with it. So whenever you create a DB, this is the code that evaluates. Whenever you add a database column to a database, that's what happens. If you set the code of a given handler, this is what happens. So this is the big function that deals with that. I forget what verify does, so I will ignore it. There's not really much else to say here. We save and load these canvases to Postgres. We have some code around that. I don't think that's too interesting or out of the ordinary. Delete, save IDs, etc. So that's pretty much all there is for canvases. Is we have the modeling for a canvas. We have a bunch of helper functions for manipulating the canvas, and we have the storage, the back and forth to Postgres databases of those canvases. So all of your Dart code is kind of managed through this canvas construct and the handlers. We did just touch briefly on op, but we can chat a bit more about it. These are just some helper functions related to ops. So these just allow us to stringify them for different purposes. Yeah, I'm not. This probably isn't worth actually going into too much. Yeah, just different helper functions for dealing with ops. We. Okay, I need a break quick. Okay, I've decided to generally skip over the serialize.fs file, but the general idea is that this puts data in and out of the database. This is another one of the files that that interact with the database. I think this could realistically be renamed. Serialize isn't a great name. It's kind of more like IO, but it'll do. So we store and fetch certain data from there. I'm not going to get too much into it. The next thing to take a peek at is undo.fs. As I mentioned earlier, Dark has infinite undo and redo. At least it claims to. We saw a few minutes ago it kind of broke briefly. I'm not sure why. So this is these are just some helper functions. In fact, just two helper functions that allow us to support undo. And finally, init. Most modules, as I mentioned, have some kind of initialization that's relevant to them, or most projects have some initialization rather. And this here initializes connection to a database and initializes our event queue, which we'll touch on in more detail later. But that is lib backend, at least a fair amount of it. We'll touch on other specific modules here as we get to them or as they come up. There are a number of parts of the standard library that cannot be executed in the editor itself. So for example, previously we saw that 1 + 2 here can result in 3, and we don't have to click this button at all. It just kind of happens automatically. So for certain things, they have to be executed on the back end. The traditional thing I think of with regards to this is something like a database connection, where it just wouldn't make sense for the client to do. I mean, sure, you could maybe set up the client to have some HTTP connection to the database or something like that. But generally speaking, you're just not going to want it to run on the client. Similarly, an HTTP client could be run on the client in the editor if you really wanted it to. But because it's impure, the HTTP call, and because we want to save the results and whatnot, it makes more sense to be run in the backend all the time. So there's certain parts of your code that can be in here, and that's what we saw were in the kind of the non-backend standard library and the Lib.Execution standard lib. But as I'm leading up to, the backend-only standard lib is the stuff that can't fit in there for some reason or another. And so I want to take a quick peek at that. First off, there is a README, standard library functions which need to be run in the backend through their connection to the DB, queues, external internet, etc. So that's pretty self-explanatory. There are surprisingly, no direct path NuGet references here, besides F# core, which is just F#. That said, I'm sure there are a number of different project references here, which in turn will be referencing NuGet packages. So we reference Prelude, which is like the baseline, Lib.Execution, which is the language and interpreter stuff, Backend, which is which we've also just looked at as the modeling and such of the Dark and backend and whatever. And we also reference a thing called client types or backend types. I will touch on this towards the end of this when I get to serialization. So an example of something that will exist in the backend here are these lib crypto functions. So crypto here means cryptography, not scams. So we have a number of different functions like MD5 and SHA and like these kind of functions that deal with cryptography or that help you with cryptography or security of data. in that way. So we have these three functions that must be run in the backend. The reason they must be run in the backend is because system security cryptography does not currently compile to WebAssembly. So even though theoretically, like, this is a pure function, it can't quite be currently run in the editor as is, because they just don't compile to WebAssembly well. That said, there are some functions in the other project within Lib.Execution standard lib that do compile well to WebAssembly. So you'll see libcrypto here with a function or two. Yeah, SHA-256 and 384. For some reason, these functions do they do compile to WebAssembly well. So anyway, that's more of a .NET limitation reason that we have something in the backend-only standard lib. Where am I? Lib. Not lib. Backend-only standard lib, yeah. So that's more of a .NET limitation reason we might have something in here. Similarly, Lib.X509. I'm not super familiar with this. I think it's something related to certificates and keys of such. But these functions only work on the backend right now. They have to be kind of in .NET space. So that those are some functions that exist here. And there are a number of other functions that we'll touch on throughout the session here, including HTTP client, database connections, and things traditionally that we would expect to see in here. The final bit that we'll touch on before we go into testing is standard lib. Very similar to the standard lib fs file that we saw in Lib.Execution standard lib. This backend-only standard lib has a similar thing where it has a list of functions, including some renames that we allow, or some duplicate names that we allow. So that's for implementation of the backend-only standard lib. Again, we'll cover more as we go. I just want to throw out that we do have tests around these functions. They're also in the execution folder that we saw earlier. I'm not going to go into what test cases we have, but just FYI, those do exist. And that is it for the backend-only standard library, at least for now. The next F# project that I want to cover is Lib.Execution. There's really not much to this, and I'm more covering this just for exhaustiveness. All it does is it pulls together the Lib.Execution, which is like the core language and interpreter, and it pulls together the standard library and lib backend to provide enough context to actually evaluate code. So basically, we have all the connections we need to database and to the language and interpret all that kind of stuff that an executable above this, API server or BWD server would be able to actually do it. So this only has one real module called Re-Execution, which is in the Lib.Execution namespace. And this provides a number of things. It provides a binding here of standard library functions, which is just a concatenation of the pure ones and the backend ones. And it has similar thing for package functions. It gathers all those. Libraries here is just a collection that includes both standard library functions and package functions. And we have some other functionality here to just gather the context needed to evaluate some Dart code. So there's really not too much to say here. I just want to do a quick drive-by. The next big topic that I want to go over is the HTTP client that's built into Dart. Any modern web-friendly language will have an HTTP client where you can do basic requests. So here I can do, let's see, github.com, Darklang, Dark. And I'm going to put no query parameters and no header in there. If I run this, either by clicking on this function play here or on the total thing here, I will get an HTTP response. It's funny to me that they prefix with a lot of white space there. Anyway, just a little odd thing. But this is the HTTP client. We have a number of different functions on this, and there are a number of different versions of the HTTP client. So you see here, this is Git v5. HTTP client has a bunch of functions. It can call with a delete, it can call with get, head, options, patch, post. So it's got all the normal verb stuff. It also has some helper functions to provide us dictionaries of content type or whatever. So there's some different helpers that are used for authentication, mostly just for different kinds of headers, really. And where to get at here? The HTTP client is implemented in the Backend-Only standard library. There are, as I mentioned, there are a number of different versions of this thing, which kind of gets a little bit hairy. I'm not going to go over every single version of this, but imagine we implemented a HTTP client, basically just wrapped around the actually the old OCaml HTTP client, and really curl, and it was released to the world, people started using it, and then some problems were noticed. It was deprecated, and then we came up with a new version, and eventually that was deprecated. So there's all these like legacy functions around this, and the HTTP client is rather complicated. So I'm not going to get into specifics of the history and everything, but I will do is I will look at two parts of HTTP client. I will look at the most modern HTTP client, which is v5, all these v5 functions you'll see, put v5, get v5, etc. And I'll talk very briefly about the future of the HTTP client. It's something I've been working on lately. So there's a lot of stuff under the hood that I'm not going to look at, but just know that if you want to see the actual implementation of these, the system, I guess, of naming that we have right now is that Lib.HTTP client v0 will expose all of the v0 functions. So we have post v0, put v0, and these all interact with the request and response in a certain way. And these are supported, these lib files are supported by these things that will just say HTTP client that will have the word lib in them anywhere. So I think, v0 of this supports v0 through 2 of this. I don't know, there's a whole mapping thing to it. But the current client that you see in your browser and your editor is this thing, legacy HTTP, that's not true, is this thing, HTTP client, which does all of the wrapping around of the .NET HTTP clients. There's a lot of kind of work done there for that. And these are the functions that are exposed. I'm not sure if that made any sense, but the point being is that we have these functions for HTTP client. The history is kind of a mess, in my opinion. And so we have all these different versions of the function available, and we have all these different modules that are kind of just littering this space. I mentioned I would speak briefly to the future of the HTTP client. The HTTP client does a lot. It assumes certain things about your request. You don't really have granular control of redirects or how your content types are contained. And more importantly, the current HTTP client is unable to take in requests or return responses that are just bytes. It basically assumes that you're talking in some kind of text all the time, whether it's HTTP text or JSON or XML or whatever. There are limitations that the HTTP client has right now. And so for that reason, in addition to these files, which are the ones that are currently exposed to the user, there's also some ongoing effort to, I guess I missed out this one. There's also an ongoing effort to define a new client base, which is here. So we have this Lib.HTTP client, and this is going to basically do nothing. It takes in bytes and it returns bytes, and it doesn't do much. You can see here the full implementation, including the actual functions that are exposed, is in like 300 lines versus even just the functions that are exposed as this. So The HTTP client has some problems. I just want to throw that out there because it's on my mind. So that's for the implementation of it. Like I mentioned, there are some like pure functions that don't need to be in backend-only space. So those will exist in the Lib.Execution standard lib. For example, there is a Lib.HTTP client there where you can go from it just returns a dictionary of content type application, form URL encoded. So there are a bunch of pure functions that are here. They're kind of outside of the other space. When I want to get there, that's pretty much all I want to talk about in terms of the implementation of HTTP client. Because things are in flux, I don't think it makes sense to go too much into it. There is some separate work done for query encoding, like the query string encoding. Oh, I got some semicolons thrown in somehow. So there is, some work here around the query encoding. How do we go from a dark value to a query param string? I don't think it's a great thing that we have this kind of tucked away here. I'm not sure if it's our responsibility to create query strings, but at least not under the hood. But these would rather be a standard library function. Right now, this is just code that's called automatically whenever you make an HTTP call. Like if you pass in, what am I getting at here? If you want to make an HTTP call and you want query strings, right now it's a dictionary. Realistically, these two fields here should just be one thing, that's just URL. And if you want to use a function to help yourself create a query string, then great. Doing it automatically based on some dictionary and some mapping process that we have doesn't quite make sense. Anyway, so we have this, and we have some testing of it, but I think eventually this will probably go away in favor of an official or unofficial function that will create a query string for you based on a map. Like anything, we have tests for the HTTP client. We actually have a lot of tests around the HTTP client. If I scroll down here to the test files, there is a HTTP client folder, and within that there are separate directories for each of the versions of the HTTP client. These are tests that are hanging around that are just ensuring that we don't break these old HTTP clients. They have a specific form to them. You can see here that there is an expected request. There's a thing that we respond with, and then there's a test. So the way these tests work is that there's a test file that coordinates looking at all these different files here. So for example, basic delete.test, and will basically create a canvas with this Dart code, or create a HTTP handler with this Dart code. It will send this request, this actual HTTP request, to this handler. And we expect, what do we want? Let me think out how to put this. No, sorry, I was going backwards. There's an HTTP endpoint that is automatically created. This here calls out to that. So this is the HTTP client. So this here calls out to that new endpoint that's automatically created. And this is the request that we expect to be passed in. So again, this here is Dart code that's going to result in this request. And this here is what we should respond with. So this response here should get this, or rather this here should return this. And this is basically parsed out and massaged into the form of an HTTP response. And then the rest of this test ensures that the response is as it expects. For example, it'll look to see, hey, is there a content length of UTF-8. So it'll check to make sure that this UTF-8 has been properly parsed from the response and returned here. So there's a ton of tests like this for each of these versions. It's a lot. So that's a fair amount of testing. As I mentioned, there's a whole there's a file here that coordinates fetching those tests from disk and running them all and checking to see if they all pass. So there's a plenty amount of work there. There's also, oh yeah, this here is regarding those pure functions. I mentioned those pure functions in the Lib.Execution standard lib. Because there are these pure functions here, there can also be these execution files here where we have some tests. If that didn't make any sense, what I'm referring to is the fact that we have these style tests for some pure HTTP client functions as well. And for some impure ones, actually. I forgot we could do that in some cases. So there's that. That's the HTTP client. There's a lot of work that is done there to implement it and test it and to ensure its stability. There are, in addition to the HTTP client itself, of course, there are usages of the HTTP client, and we have some packages that do reference HTTP client. So in the editor here on the left, you'll see like Google Access Token. There's like this function here that I can use. So I can see the definition quick here. And if I want to, I think I can go to like Google and I can use that package. So anyway, the point is this function here uses the HTTP client under the hood. Here we have v5, the HTTP client. I just wanted to make you aware that those packages exist and they are wrapping around the HTTP client. We also have some Twilio functions, which I believe are the same deal, but for some reason written into the source code itself rather than in package land. So that's the HTTP client. I hope that made some sense. There's a lot of noise there and kind of a lot of testing files, and it can be a little bit muddy. Right, after HTTP client, the next thing that feels natural to talk about would be the HTTP handlers, the endpoints that are in your Dart program that react to, HTTP traffic. There's a number of different parts that go along with this. There's the setup of obviously configuring your handler to exist and what the verb to listen for is and what the route is to listen for, and your code that you write against it. There's the routing that's used in the BWD server that basically chooses one route or another based on specificity. There's the middleware, basically the portion of Dark that takes the incoming request and readies it for your Dart code, and then takes the result of your Dart code and readies it for the internet to create a proper HTTP response. So we call that the middleware. There's the built with Dark server itself, which is the web server that's listening for different requests and reacting to them and coordinating with the middleware and such in the routing. And that's pretty much it. And those are the major pieces. We have the middleware that deals with converting between internal data types and HTTP traffic, BWD server that listens for web traffic and calls in the router to properly route from one place to another. So I'd like to start with the routing and the testing of that, and then we're going to the middleware and BWD server, and then we'll talk about the testing of all that. And then really briefly, I'll talk about the future of HTTP handlers and kind of where our brain's out there, since those, similar to HTTP client, are a bit limited currently. So first off, let's go to the routing. So routing.fs is in lib backend, and this is in charge of a few things. You can imagine that each of these endpoints can have a route configured to it. So here our route is really boring. It's just hello, but you could have path parameters to it. So I could do hello/name, and instead of checking the query params, I could do, what is it? Path query params. What is this? Path? Or maybe it's just, yeah, it's just name actually. I could do this. And so I could do hello/stashu. Oops. And instead of looking at the query params here, it'll instead look at the argument name. I'm surprised here. Oh, I was looking at this. Anyway, so the routes may be not boring. They may be something other than plain text. In fact, we can have this path argument, and then we can continue to do something else, or to have other parts to the URL. So the routing.fs is a module that's used to deal with the routing, to either, to basically extract values from routes, to turn those values into inputs that are usable within your Dart code, and probably, and then also compare specificity of different routes to determine if there are multiple routes that all match the incoming URL, which one do we choose? That's all handled by routing.fs. And then also some custom domain stuff. You can host your endpoints on custom domains, and there's also some coordination there. I won't go into testing there, but you get the point of the fact that Dark has to deal with these different routing challenges. The next part, once the built with Dark server, neat. I wonder where I got that. Once the built with Dark server is determined what route you're going to deal with, is the middleware, and the middleware again is the piece of Dark that that takes incoming requests, turns them into Dark objects that we can interact with within our Dark program, and then takes the responses and returns those into HTTP, or turns those into HTTP responses. So it's kind of the middleware between outside world and your actual Dark program. Similar to the HTTP client, the HTTP handlers currently do too much. They assume things about your content type, and they just do all kinds of things that are unnecessary and remove control from users. It is convenient for the first version of these handlers to do all these things. You don't have to think about them when you're creating simple endpoints, but it gets in the way if you're trying to do something complicated or more granular. And to that end, we are working on a new form of handler that we're currently calling HTTP Basic, which does basically nothing, which just takes in your request in bytes and returns your response in bytes. So that will allow a lot more granularity. Anyway, that's all I want to talk about for the middleware. BWD server is the server that that listens for endpoints. In fact, let's see what it says here. This is the web server for built with dark.com, often referred to as BWD. All Dark programs are hosted with BWD. Our grand users hit the server. That means anyone who's using your programs hit the server, and BWD handles the requests. It uses ASP.NET directly. So this server here doesn't have any like Giraffe or something like that. As a web framework, it deals with ASP.NET Core directly. So we have granular control and performance and all that kind of stuff. There's a lot to be said about BWD server is like 700 lines of code. I do think it's interesting and worth going over, but at the same time, I am honestly running out of energy in this thing. But the general sense is that, let me get to the important part here. Okay, so where do I want to get to here? Yeah, so Dark or BWD server listens for requests, and if we determine that is a proper Dark request, then what we'll do is we will run a Dark handler. And so what that will do is it'll extract the canvas corresponding to whatever request is coming in. So for example, this endpoint here is stashu-demo.builtwithdark.com. And so it can extract stashu-demo out of the URL to get the canvas name. It'll determine the user as well. And from that, it will fetch everything it needs to determine what handlers are available in that canvas. So it'll first find what canvas we're looking at, and then fetch all the relevant handlers, and then choose a specific handler based on that. So it'll choose which one basically matched its route. And then this is the part where we have matched a route and we want to actually process the built with Dark request. First thing we do is we extract the route variables. We will extract the route body or the request body and the request headers inquiry. And we will pass all of those into your into the middleware to then be presented to the to your Dark program. So basically, we extract all the incoming stuff, we tidy it up, and then we present the data to your Dark program so that you may use it in a request and have .cookies, .body, .whatever, if you can get all those pieces of data. And then based on that request, we will execute the handler. Again, your handler is your Dark code. We will execute that Dark code and get a result back. It's a deval. And we will then use the middleware on the other side to turn that Dark deval into a proper HTTP response. So that's how BWD server interacts with the middleware and your program. Again, this is all doing a little bit more than it needs to do. And for that reason, we have work in progress around fitting this out a bit to have a thinner middleware available to you. Along with all of that, there are, of course, tests, lots of tests. Similar to the HTTP client, we have many HTTP handler tests. If I scroll down a bit to test files, you will see an HTTP handler folder with an HTTP folder inside of that. This is the current HTTP handler. That's, again, as I'm noting, more complicated it needs to be. Each of these tests are in a similar format to what we saw with HTTP client, but instead of automatically hosting an endpoint that we listen for and explicitly turning a response, this does something a little bit different. What we do is we have a Dart program at the top, which is configured really simply. We basically say, hey, we want an HTTP handler that listens for GET requests on this route. And whenever we get such a request, we want to return hello world. So that's the Dart program that we create. And then we say, here is the request that I want you to send to that handler. So we specify the handler and the HTTP request to throw in. And what we're doing is we're expecting a certain response. We're saying, okay, what should the built with Dark server respond given that context, given this request in this path? This is a really boring test. Let's see, here's a slightly more interesting one in which we have a handler containing a route involving a parameter value, and we're able to use that value within this. So not too interesting, but pretty neat. But we have a ton of those tests that I'm not going to dive super deep into. The last piece, I'm not sure why I listed this separately, but we have HSTS support, and we have a file around that. I forget what HSTS stands for. Oh yeah, something strict transfer security header. I don't know, some security related thing that is related to BWD server, or that we support on BWD server. So those are HTTP handlers. Hope that made sense. The next topic I want to go over is passwords and secrets. I have done very little with these, so I'm just going to brush by them. Just quickly, passwords again are, I think the only usage is the, or the secrets that we have, the secret values. You can see that they're hashed here at certain points, or masked rather. We have this password module in Lib.Backend with a password type defined and some minor helper functions. We also have a secret module defined in which we get, insert, and delete secrets within a canvas. And we have tests around those. So we have a password tests in which we check to see that if we hash a password and then check to see if the password is correct based on that hash value, that it is correct. And then finally that password hashes do not equal each other. So if I try to hash the same password twice, it doesn't get the same value. This is just kind of a security bit. The final bit relevant to passwords is lib password, which is a oh, I guess it's not. Sorry, I misspoke before. When I claimed that it was only relevant to secret values, that's not the case. We have the ability to hash some passwords here. So it's more of a function. So if I do password hash of test, I can execute that, and I have this, well, I guess redacted password. And if I do it again, what am I doing? Let's see here. It's going to say false because I'm not sure why this is expecting different values, that test. But in any case, this avails two functions for hashing and then checking passwords. Oh, the fact that these two are matching is probably a editor-specific thing, actually. I don't think that's something to worry about. Basically, because we're masking the passwords in the editor, I believe this is checking to see, hey, is it masking to be the same thing? And that's not really a fair comparison. Anyway, so that's it for secrets and passwords. And really just passwords. Secrets are a separate thing, so I shouldn't have conflated those. Okay, the next bit of Dark I want to touch on are user databases. Actually, again, these are just the data stores here. We've previously seen the definition of these in program types, where the columns and such are modeled. But now I want to talk about like how it actually works. So there's a few pieces here. There's the SQL compiler that allows you to query user databases. There's the general ability to insert and fetch data from the database and the functions that are available as part of that. And then, of course, there's a bunch of tests. So let's get in. The first thing I'll look at is UserDB. This is anything related to data stores on a user canvas. So mostly managing user data. So we can extract the fields of a data store, what fields exist there, ensure that data going into a database is of the right type. So a data store is expecting, in this case, string date for title, body, release date. If we try to insert the wrong types of data in there, this ensures that we complain about that. Set here is what allows us to insert data into the database. So like a database set is kind of like an insert in this case, since it's key value storage. get option. I think this is just like a find head maybe, like if there is an option. Sorry. Get option is like a get, but returns an option in case there isn't something that matches the criteria, specifically the key. Get many with keys, get all, you get it. There's a bunch of functionality here that allows database IO, our database IO for the user database IO. Most of this file is supporting libdb and libdb2. These are the database functions that are exposed to users. libdb is deprecated. These are all old style functions, so I'll focus on libdb2. This is not be confused with db2, the database. But anyway, we have, for example, dbset, which allows us to upsert a value into some data store. And these are all using that user DB module that we saw a bit ago. We tend to split if we tend to split the function declarations from the implementation if the implementation becomes huge, which is why those two are split. Those two are also supported. Oh yeah, so one of the functions that you'll see down below, query, ironic. Oh, there we go. We had a query function here. This function is used to fetch a bunch of values in a table, matching some criteria. And as part of that, actually, I guess this might not be, yeah, this is it. OCaml compatible spec param. I'm not sure what that is in table param. Yeah, anyway. As part of Dark, let me back up. When you're fetching data from Dark, and I thought I had a REPL here to do this, although I might have updated it. I suppose I have. For blog, and I'll say true. So in addition to be able to just fetching all values of a data store, you can also fetch based on some criteria. But this condition here, this parameter, must be something that's quote unquote SQL compilable, just something that we can translate into PostgreSQL that we're able to access. And so the fields, is it fields? I guess it's fields. Oh, nope, never mind. I was looking at the wrong thing. I was looking at query 1. I want to be looking at query v4. There we go. This is what I wanted. I want the function that takes in a table reference and a query. And so what happens here is this query that we're provided is lambda that is basically converted into SQL. And throughout different functions, I noted that there's a SQL spec here that indicates whether or not it should be compiled into SQL or not, or whether it's able to be compiled into SQL, or whether it's able to be inside of a query expression. And so SQL compiler does the job of, nope, not there, of taking those devals, those dark values, and other functions and inlining them into a SQL expression. And those are tested by DB tests, I believe. So we set up a number of databases here, and then we have tests. So let's get to a query v4. And we have a lambda. I guess here what we're doing is we're saying, give me all of, no, I was looking for this lambda. Oh, this is a function. I see what's happening. Within this test file, what we're doing is we're defining a user function called friends, which takes in a lambda, and it will basically query that function for us. So I want to look for something calling friends, and here we go. This is an example of an expression that is compiled down to SQL. There's a bunch of these if you look through. I'm not going to go through all of them. And of course, there are tests around that SQL compilation in SQL compiler.tests. And you'll see the resultant SQL throughout a bunch of these tests that I'm not going to dig into. So those are user DBs. I went through pretty quickly, but if you're interested, I would recommend going through the DB tests and going through the SQL compiler and such. I haven't spent a ton of time here, which is why I'm kind of breezing by user DBs. Okay, at this point, I am near the end of this list, and I realize that I have very little context for traces and very little context for how user accounts work. And I feel like I've breezed by a few of these topics, and they haven't been super useful to go over. So I'm actually going to skip these two topics and go into these final few topics, which I think will be more useful and interesting. All right, the first of these final sections is the client and the editor, and how the how the editor interacts with the backend. This is generally through a project called API Server, which we'll find in the source just above here, which is a relatively small project. I guess we'll look at it quick. We'll look at the README. This is the web server serving the editor and the API used by the editor. So it serves the HTML that we see here and the JavaScript and all these assets that are used for the editor, and all the things that anytime you want to interact with your program, for example, if I change the position of this, or if I change the code of this to this, all this is happening with the editor. In fact, if I open up my network tab, I should be able to watch the traffic here. So if I move this around, you saw that I have done an add up where I've done a operation, and the specific operation here, I'm sure if I were to look in, would involve the position changing. And this is happening against the darklang.com/API endpoint. So API server is the executable web server that is in charge of all of this. I'm not going to be covering the actual client code as part of this video. There is a whole folder of Rescript front-end code that deals with the client. So all the UI and such here, and the front-end interactions with everything are defined in client. But back to API server. We have, let's see here. There's, of course, the README, which is not too much to say. There are some package references. There's not too much that we reference directly within here. We reference many different projects under the hood, but mostly Lib.Execution, Lib.Backend, Lib.Real.Execution, which ties those together, and some serialization stuff, which we'll get to. So API server, there's a number of routes that are exposed. I'll jump to the part where we expose some routes in the main API server.fs file. If you scroll down, you will start seeing the section where we add routes, where we add a login route, some logout routes, routes to add operations, register tunnels, delete 404s, etc. Pretty much every user interaction that you're doing when you're clicking around in here or typing some code is going to be coming through one of these endpoints through API server. In addition to the initial payload that actually brings up this header. So that's what API server's job is. There are modules that are kind of base level dealing with HTTP stuff. There are middlewares specific to API server of how we handle redirects and session data and user info and permissions and such. Permissions are particularly important to make sure you can't access someone else's code or if they can't access yours. There's a permission around login and logout and session management. I think these are generally not specific to Dark, so I won't go into a ton of detail about them, but they do exist if you're curious. There are a bunch of actual API endpoints, so these are all relevant to different parts of your Dark canvas, whether you're working with 404s or adding a new operation or dealing with databases or whatnot. Each of the endpoints that we saw a minute ago inside of API server FS that are registered have a corresponding module here with one or more routes dealt with. So for example, here, let's do secrets. Let's say I want to fetch the list of user secrets, or I want to delete. Yeah, I'll insert a user secret. Here's the endpoint that handles that. We take in the request. We call our internal function where we actually insert the secret, and we gather whatever secrets are now in that canvas in total, and we return all of the secrets to the client. So anyway, so each of the endpoints has a module corresponding to it with one or more endpoints, the implementation of one or more endpoints, and most of these are pretty thin. There are simply mapping between internal types and external types, calling some internal thing, getting the result, and then mapping back to whatever external type we care about. So not too much to say there. What is in functions? Oh, okay. The way the client actually knows about all of these user functions like addition and whatnot is because when we load this this HTML of your actual Dark canvas, we include a list of those functions in the HTML. In fact, if I hit Control U here to look at the source, and if I scroll to the very bottom, you'll see that there's a few things that we inject. I have to make sure these tokens can be removed or published or whatever. But you see down here, we have a list of functions that were included as part of that payload. And so this is just something that helps us gather the function list. The actual bit that returns the HTML and gathers these functions and other pieces of data for the client is in UI.fs. This first off deals with some admin specific pages, but more importantly, allows us to return, where is it? UI handler here. Where's the, oh yes, so here's the an API endpoint that returns the HTML for a given canvas. This is what's going to gather it's going to fetch the HTML from disk. It's going to inject all of these different pieces of data that we might need in the client, such as the user's full name and all functions that can be operated with, etc. So this is in charge of the of returning the UI HTML. We have two HTML templates. There's not too much going on in here. There's the login page, which just allows you to log in, nothing too much going on there. And we have the UI HTML, which avails all the spaces for you to inject data into, as we just saw in UIFS, as well as references the app.js that the front end actually compiles to. So all the real functionality to the client is bundled up in a single JavaScript file, at least mostly. That takes care of templates. And then, of course, we already saw API server FS is the thing that connects it all and sets up the endpoints. So that's API server. It is tested by API server tests.fs. Which looks like this. I haven't looked at this in a while, but I assume it tests a bunch of things about. Actually, I don't know. I'm not actually sure what tests are in here. I haven't looked in a while, so I'm not going to cover that. One thing that I will cover, though, is Pusher. So we use a service called Pusher, which will send updates from our server to the client here. It basically acts as like, like an RTC, or real-time communication kind of thing. Actually, that's not true. It's more just a general server to client communication. For example, let's say there are 2 people working on your canvas. In my case, there's just going to be 2 of me. When I enter it a second time, this server is going to send some information to a canvas, and basically what's eventually going to happen is a message is going to be pushed from the server to this client telling me, hey, by the way, there's a user here. You can imagine that there are a number of different cases in which a push from the server to the client can be useful. For example, another one that we saw earlier is when we went to a URL before it existed. In the 404 section, as soon as I went to the URL that didn't exist, I could see it pop up here and I could click on it to create it. So there are a number of cases in which we use Pusher as a means to do that communication. The next thing I want to cover is a thing that we call analysis. I've been hinting throughout I've been mentioning throughout this video that there are some times in which we can execute code directly in the editor without having to go to the backend. For example, I can do basic math here really quickly, and the editor is immediately responsive. I have the actual thing here. But there's also cases where the editor needs to reach out to the backend to help evaluate some bit of code. The process of evaluating an expression within the editor itself without reaching out to the backend, or to replay a previous execution, is what we call analysis. And this is pretty interesting because it involves some WebAssembly compiled or blazerized code. The short version of this process is that we have 2 FS projects, libanalysis and analysis. They don't really need to be separated. You can imagine this is all one big analysis project. But the short version is we have this function called perform analysis. This takes as argument a request for analysis. Let's see here, client types analysis. Client analysis types. That's probably what I want to get to. It takes in a request. Sorry, 1 second. CT analysis is what I want. It takes in a request to either analyze a function or a handler. These 2 things basically look the same. They involve when the request is going to be made, an identifier for the request, what user function should be or handlers should be evaluated, some details around trace data that we may or may have present, and some other stuff, which mostly involves, I think, code that may or may not be referenced. In any case, it basically makes a big request for like, hey, here's a bunch of code and trace data. Please evaluate the expression given that context and return it to the front end. So this F# function exists, and it's called perform analysis. And the question then becomes, okay, well, how do we call this F# code from the front end so we can do it so quickly every time I type a character? And so that happens via a Blazor compiled assembly. We have this other project called Analysis, which is Blazor WebAssembly compiled with ahead of time compilation for performance boost. And this results in a number of artifacts that we interact with. Specifically, if we were to look at the build artifacts of this, and this takes a little bit to compile, by the way, because of all the AOT stuff. If we look at the build artifacts, we will see a bunch of normal stuff like DLLs that we would expect in any .NET build artifact. But we also see some .NET WASMs and .NET.js, and some other stuff that's a little bit interesting. I think if I look in the publish folder here, in the www root, I'll see what I'm actually looking for. And that is this Blazor boot JSON. So what Blazor effectively does is it looks at your fsproj, among a number of other things. It compiles it all down into one or more assemblies, especially referencing assemblies it needs to support itself. And it'll compile it down to the assembly, and it'll also output a Blazor boot JSON file. And this is I like to think of it as a directory of basically how it can be loaded in the WASM world, like what other assemblies it needs to load and whatnot. So it'll load all these assemblies and run them in Blazor, and we have this whole setup around that. So this is something that Blazor will naturally output, this Blazor boot JSON. If you ever work on a Blazor web application, like a traditional one where there's more, what am I going to say? Where there's UI to it directly, I believe you'll typically see a Blazor boot JSON artifact as well. We have a I'm trying to think how to put it. This normally also comes with this other file called Blazor WebAssembly.json, which is used to interact between a normal client and a normal Blazor WebAssembly compiled .NET assembly. But we have a slight complication, and that is that the bit of code that runs analysis is running in a web worker. So it's running in a different thread, and because of that, the normal Blazor WebAssembly loader doesn't quite work out of the box. It assumes that you have access to the document, or I don't know, it assumes certain things about your setup. And so what we've had to do at Dark is create a specialized Blazor worker, which basically forks an old copy of that kind of Blazor WebAssembly thing and thins it down just to the points that we need, and it basically loads our Blazor resources the same way that Microsoft's official support would do, but kind of in a hacky way. If that didn't make sense, the short version is we had to do some hacky stuff to be able to get Blazor WebAssembly compiled code to run in a web worker, which is a separate thread than the main UI thread of your web client. When Blazor has eventually loaded, we do a few things to start up. We first off, we call an initialize function that will in Blazor, in the WASM world, will initialize some serializers and set some environment variables so that our code executes correctly. And then we will set up this message handler such that every time this web worker, this is a web worker at the end of the day, every time this web worker receives a message, we will take the incoming data and we will call the internal .NET code. This is the on message of eval worker. And then it'll return the data. So if we look at eval worker quickly, I realize I'm jumping a little bit here. Eval worker is just, at the end of the day, some function, some module that exists in JavaScript or / WebAssembly land and listens for messages, which are then deserialized and processed and analyzed, and eventually posts back messages to the header, or to the host. So if you're not familiar, there is a what's it called? There is a thing called post message that is attached to Windows, where you can send messages to and from different UI pages or different browser instances, whether it's tab to tab or iframe to host or host to to web worker. You can communicate using this window.postMessage thing. So this is just calling window.postMessage with this, and then there's a listener on the other side. So there's like this hacky back and forth dance we have to do to get messages to go back and forth. But at the end of the day, it allows us to get like instant feedback within the editor rather than to have to always wait for the back end. I hope that made some sense. This it is a little bit complicated to get it all working, but if you ever want to see in more depth how it works or ask more questions about it, definitely check out this analysis project, especially the Blazor worker and this analysis FS file, and also some client code for how we interact there. All right, I think the last section that I'm going to cover regarding Dark, because I'm running out of steam, is going to be some little bits inside of running Dark. And by running Dark, it just means stuff that users don't really need to worry about, but we do, including the safety of your data and whatnot. So there are a number of different things we have inside of lib service that'll help us out. For example, we have telemetry and error reporting and logging and feature flagging and connections to Kubernetes all set up there. Not too much to talk about, but we have various modules that deal with those connections. We have some internal standard library functions that we've defined. If I go to libdark internal, you can see that there are functions. Let's see. For example, if I need to create a new session for someone's username, there's an internal function for that, for deleting someone's session, etc. Basically, any case where we would like to be able to write a Dark program reaching into something internal but not expose it to normal users, we use libdark internal for that. And of course, we have a number of tests around Dark internal functions. We have our own database migrations to deal with. I don't think there's anything too interesting there. We have a module that calls a bunch of SQL files of migrations. There's really not much to say. It's just a hand-rolled database migration script. Speaking of scripts, we have exec host, which is a small assembly, which is kind of a backdoor to be able to do one-off actions as a Dark admin. It's used for logging in case of emergencies, let's say auth0 is down, or running database migrations like we just mentioned, or what else can you do? You can trigger roll bars or whatever. There's a few things you can do, but really not much. More for like emergency situations or migrations. There are data tests. I've never used these, so I won't speak to it. I don't think they're super relevant. There are fuzz tests, which were super useful when we were converting all of the backend from OCaml to F#. Recall that all of the standard library functions were written in F# and they were ported from OCaml. Well, those are pretty different languages. We had to make sure that there was 100% stability between the two implementations. And so what we did is we used fuzz tests to ensure that that the results were the same between the two backends before we fully cut over to be using the F# backend for our users. So we haven't used fuzz tests in a little bit, but those were really, really useful. Those all use fs check, I believe, for the generation. We have integration tests, which are not in the backend directory, but do exist, and they touch both on front end and back end. Where do we have them? So we have the integration tests here. You can see the actual test list here. Under tests, you'll see a bunch of integration tests that reach out to the back end and front end and whatnot. And the only reason I'm mentioning as part of this video is because the files used for the sample canvases, or the canvases that are used in these tests, are all defined within this test app data folder of the backend. So under backend test app data, you can see editing stays in same place with enter. This is a encoded list of ops or operations, which will result in a canvas that is tested in our integration tests. Anyway, I just thought I'd mention that since the folder is technically in the backend. And then the final piece is around serialization. I feel like I've been building it up throughout this video of, oh, I'm going to talk about serialization later. But in reflection, there's not too much that happens that's interesting. There's really three kinds of serializations we deal with. There are some old school serializations of devals or dark values. Those are like this, like we have some kind of dark type or data or something like that, and we want to stringify it. We have a number of different modules that handle this. I don't know if we'll stick with those systems long term. In fact, you can see a kind of funny naming system. We have this deprecated, new, external, and then also developer, just these different ways to represent these dark values. So these exist. Some of them are, I believe, exposed to users. But generally speaking, besides like one thing for developers, so they can like see dark functions in a reasonable way. I don't know if that makes sense. But anyway, we have these deval wrappers. I don't think about them too often, but they do exist. That's one kind of serialization that we have. One more that we have is storing your programs, your dark code to disk. And that is done through a separate set of types we have called serialized types. There is this file here in source libbinary serialization where we have a bunch of types that are decorated with message pack attributes. I am not super familiar with this, but from what I understand, message pack is a NuGet package / tool that is used to help us format and save these different kinds of data in a safe and concise manner to disk in our Postgres database. So we end up mapping between these serialized types that are like super, super stable, do not ever break them. If you break them, everything will break, to these other, program types, which are safe to update over time, really safer. The main point is, though, that we have these serialized types that are tucked away in their own file where we know I am not allowed to remove some column or something like that because it will immediately just break loading or saving to our Postgres databases. So as long as no one messes up this, everyone's program should stay stable and safe. And of course, we have test files that ensure that no one messes up. So even if someone were to accidentally remove a field like this, we have various tests that ensure that protect that stability. And finally, the other kind of serialization that we've had to worry about, and specifically I've spent time on it recently, is the communication between the server, namely the API server, and the client, again, written in Rescript. We previously used our, let's call them internal types, and we directly expose them to the endpoint. So in other words, let's say we have let's say you're loading your canvas and it includes, of course, some Dart code. All of the types that were pulled from the API endpoint were referencing internal types, things in Lib.Backend, Lib.Execution, etc. And so there was this fear of updating any type within, let's say, Lib.Execution, because, oh no, well, what if the client is expecting a slightly different shape of the type and things break? And so we did something that's not particularly creative, but is particularly useful, and that's called client types. Other people might call them DTOs or data transfer objects. All they are types that match directly to types in the client code base. We have, client program types, which basically look like the program types you've seen before. But we have them, and we put them again in a safe place where we know that they should match the things in the front end. So we have the core actual client types themselves. We use these in API endpoints. We use this in the UI HTML that I mentioned before, that the API server basically injects a bunch of data into the bottom of the HTML of this page. We use them in pusher notifications. That's the service that we use to push messages to the client while the server's running. What else do we use them for? I think that's pretty much it. Yeah, we use them for mostly API endpoints, and both requests and responses. So we have these types defined, and then we have some modules to map between internal types and external types. And naturally, we have just a ton of tests around this. This doesn't look like a ton. We have this test module here called serialization.vanilla.tests. This basically ensures that all of the values that are registered as serializable types are serialized in a stable way. So what we end up doing is we take a bunch of F# values, and we serialize them to disk, and they end up in, oh, not there. Here? Yeah, here. They end up in this backend serialization folder, which probably should really be also inside of test files, like here. But they end up being serialized here. And so later when we run tests, we ensure that if we update any types, that we get some test failure telling us that we need to be more safe about something. All that's to say is serialization is, it's a complicated problem, but we have a bunch of F# code protecting us from screwing it up. And similarly, we have a bunch of client-side code that ensures that it can handle things the other way around, that the full stack of encode to backend and then decode in the response to the backend, that all that's working. There's some miscellaneous stuff I didn't cover. I don't think I'm going to. Nope, none of that seems important. All right, I've been talking at my computer about this F# code for hours now. I am officially tired of looking at these slides and code and whatnot, but I'll wrap this up. I hope this was useful to someone. If I would have had this video a few years ago, I thought it would have been great. There's a lot of interesting F# code here, but it can be sometimes difficult to dive into a code base and not have like a tour guide. I think it's really easy to get lost. So hopefully I've been that tour guide for anyone interested. Anyway, so that's Dark, what Dark is. That's how Dark works in the back end at a long but still quick pace. If you're interested in checking things out more, I mean, please, join Darklang as a user, because it is it's a cool product. I like it. Check out the app, the blog, the docs. I wrote app twice. It's really important, I guess. We're on all the social stuff. Discord is the main means of communication, in addition to GitHub, of course. We're on Mastodon. Paul has been streaming a lot to Twitch. I might try to get into it soon. We also upload to YouTube. Twitter's kind of dying out, but we still have one of those. Yeah, use it. Check out contributor docs. Have fun. Mostly just join the Discord. At this point, I would do like general reflections. So I mentioned I've been thinking about Dark for over a year, but working at Dark since February. It's been neat. General reflections, like it's been a lot of interesting work. I mentioned at the beginning, it's a totally different domain to me. The interpreter stuff has been fun. There's a lot of interesting client-side work. It's been fun working with my boss Paul. He's great. We share a lot of values. So overall, really fun. I think there's a lot of interesting technical challenges still ahead of us, and there's a lot of work to be done, just generally speaking. So looking forward to that. Just a quick reflection on like the stuff I've done, just to brag for a minute. The initial thing I did was porting the HTTP clients from OK F#. I helped with a number of other F# porting efforts too, especially the fuzz testing. The WASM analysis stuff that we showed before, we had a number of issues with that had to be resolved. I've added and removed some standard library functions, done a lot of editor stuff, especially related to tuples, which I've been working on, which I'll get to in a second. I've done a lot of work on serialization, which is probably why I was building up so much while I was talking through things, and just a bunch of internal stuff and other things I've stumbled into. There's a few things that I'm in progress on. Dark doesn't really have tuples right now. You can actually use tuples if you opt into them. If you go to contributing and opt into tuples, then you can, add tuples of any size besides one. Where was I? Anyway, so I've been working on that. There's a lot of work to just adding a language feature because the editor is baked in. Anyway, the editor is complicated, but necessarily so. The as I keep on mentioning, the HTTP client, HTTP handlers are still, they do a bit much and they don't provide you with enough control. So I've been working about getting those out. I've mentioned that static assets are a feature here. We're actually thinking about deprecating those. They don't seem like a thing that's core to Dark. Don't know exactly how it's going to pan out, but probably going to be deprecated. The queue worker is able to be hogged right now. Someone can like shove a bunch of events into the queue, and it can fortunately block other users' events or queues from being processed. That's a problem that I'm trying to solve. And right now, I get a daily email sent to myself from Dark via a cron, and I am very tired of it just saying daily, not having like daily at 7 a.m. So I would really like better timing control. So I can get it like 7 a.m. What I actually want is for it to send an email and then basically print to my printer, so I can just like get a piece of paper of like, here's my weather report and my daily news and that kind of thing. Like as some general desires for Dark, I want to use it as a backend dev because I don't want to deal with all the BS that comes with normally developing backends. But I also want to use it to like manage my life, like in a really nerdy OCD kind of way, where like, my life is typed and all of my data is entered via Dark, and I have like ways of manipulating all the data really well. Hard to fully explain, but I have this like vision for what that'll look like in 5 years. So I'm hoping to move Dark slowly towards that, but we'll see. Obviously, general desire is more users, more contributors. I've mentioned some product improvements at top of mind. But there's some stuff that I haven't touched on yet, which will be fun to tackle at some point. The editor right now is janky and lacks a few things like proper types. There's no way to like write tests in Dark, at least not officially, so that's got to be done. Same thing with like database migrations and refactors and packages and WebSockets. There's infinite stuff to be done. But that's it. I just want to go through the F# of Dark. Again, I've been working on it for a year. It's been fun. Follow me on various places. Thank you to Sergey for hosting this. F# Advent is a thing I look forward to yearly, both as a contributor and as a reader. I end up just reading them all at the end of the year when all the posts are out, because otherwise I'm not good at just reading something daily. But more as a contributor, it's a great way to force me to think about something F sharp at least once a year and put something out about it. This is actually my 6th F sharp advent, just a tiny brag. So anyway, I've been really happy that it's been pushing me to do more and more F sharp over the years. And I'm looking forward to doing more in the future. Anyway, thanks for watching. If you'd like more Dart content, or for me to explain something, or if I went by way too quickly and you'd like, just more explanation or to learn maybe about the client, ping me or just join the Discord and we'll see each other there. Thanks.